like this one. It's actually kind of a fun one. This is not so bad. I don't think this is so bad of a question, right? Here, let me put this on a new page. Let's go over to a new page. Dun, 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 dun. Yeah, well, yeah, that was from like on the 8th. Yeah, one sec. Let me pop up my chat too. Stop. No. Okay, cool. There we go. There we go. Okay. This has a radius of 1. Yeah, I don't think it's too hard either. And this is a radius of 3. Oh, wow. Okay, I see. Oh, also, that is really loud. Whoa, 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 whoa. Okay, better. Well, okay, let's see what the area of this is. Okay. So, in X, yeah. So, I assume that, let's say this is an angle in X degrees, okay? Then the area of this region, let's say of like the O region, let's say area of O, is equal to, that's going to be pi times r squared times x degrees over 360, okay? Well, actually, sorry, it's 1 minus that, right? It's 360 minus x over 360 degrees. Because x over 360 tells me the percentage of this area that is in the white. Because the nice thing about area and angle is they're linearly related, okay? So, if you have half the angles, you have half the area. Yes, good. Yeah, I think Jamarcus got it right. Yeah. You say 360 minus x over 360 pi. Yeah. Okay. And r here is 1, which is nice. Cool, right? So that's the area of O. Area of P. That's this, which is, well, so it's this whole area minus this. Oh, this is really interesting. Okay. So this is pi times the big radius squared, which is 9. So that's 9 pi. So 9 pi times x over 360 minus this amount, which is the pi r squared of the small one. So that's just pi x over 360, right? Because that's what this is, I think. Yeah, okay, cool. All right, so we want these equal to each other. So I have 360 minus x over 360 pi is equal to 9 pi x over 360 minus pi x over 360. I kind of see some things canceling here. Do you see how I have like a minus x pi over 360 minus x pi over 360? Yeah, so these are going to go away actually. So this one goes away, which is nice. Goodbye. Okay, this all goes away, pretty sure. Okay, so now we're just left with this. Oh, which just has x on it. This is nice. Okay, the 360 goes away too. Goodbye. That's easy. Pi goes away. That's easy. So see, what are we left? What are we even left with at this point? 360 equals 9x. Okay, cool. X equals 40 degrees. This led me to noise, which led me to learning calculus and trig and linear algebra, which led me being able to do my quantum physics. But yeah, nice, dude. I'm glad, Jamarcus. I'm glad this server has had such a positive butterfly effect on you. Yeah, it's a good thing. Yeah, is the answer just 40 degrees? This is one of those Pascal tests, right? Ooh, we got solutions. Let's see what they got. Okay, cool. I like the solutions here. Oh, it's the Cayley contest. What's the Cayley contest? Okay. Why is it named after somebody else? Answer's 40 degrees. Nice. Didn't the pi x automatically go away? Yeah, but there was, Jamarcus, there was still a pi on the 360 here. Yeah, the pi x over 360 went away with that. Yes, equity. Yes, I'll give you preference. And Jamarcus, yeah, I'll help you. You're good. Yeah, you're fine. Don't worry, I'll get you your gift card regardless of what happens today. Because you're active. It's fine. Okay, go away, Mr. Skibidi. Nice. That's a good question, Shantrix. It's so delayed for you. I'm sorry. Yeah, I will work to make. Oh, it did a more logical solution, or is it? Let me just see what they did real quick. Since then, the unshaded region. I see. Okay. Yeah, the 1/9. Okay, and then 1/9 to 360 is just 40. Yeah, that's cool. That's definitely a more elegant solution. I tend to just fucking brute force things. I'm like, I will find an answer. It will happen. Okay, cool. All right, let's see. Good job to Shantrix. Yeah, I'll help Equity because I didn't get to do his question last time. I had to end the stream early last time before I got to Equity because the fires were like getting really close. So I'll do Equities now. It's okay. He has technically been waiting like 6 days. All right, let's see. Oh, that's a good question. I like this one. Okay, cool. All right, let's see. Find the extreme and where they occur. If there are none, cross it off and write none. Ooh, this is always this is kind of. He's invited like 200 people. I will process the invite coins. I meant to do that at the beginning of this year. Again, just life just keeps getting very lifey. There's too much life stuff going on at this point. I need life to like chill out for a bit. I was gonna get like stuff on track last week. I was like, all right, cool, new year, let's like do some stuff. And then yeah, the fucking city burned down. But there are some slight good news. So remember how I told you guys I was applying to maybe teach at UCLA for physics? It was supposed to be for this quarter, and I never really heard anything back, which I don't know. Ghosting culture has gotten out of control. You know, if I spend a lot of time like filling out an application, writing a resume, I even had to do some fucking diversity statement about like, I don't know, my teaching style and how I'm inclusive. Like, I'm very inclusive. What the fuck you think I'm doing right here? I finally heard back from UCLA, actually. This is what they said. They said, it looks like there's some opportunities for teaching in the spring quarter, which I was like, cool. Okay. I was originally applying for the winter quarter, which already started last week, but then again, UCLA is now shut down for the last week. It'll probably be shut down for this week too. So this would have been kind of a bad time to start teaching because UCLA is not really open. So they said there's opportunities in the spring. That starts in March. So I might be teaching physics in March. And then they said also summer, which would mainly be online, which dubs. I already teach a ton online. Like, what is this? So we'll see. This might pan out. I'm not hopeful, but you know, maybe. Anyways, yeah. 2024 was my year of rejection. I think I applied to like 10, 15 different jobs. Just nothing ever worked out. I was like, okay. Just don't give up though. That's the key thing. Don't give up. 2025 is my year. Trust.
Perfect.
I hope so. Okay. Where's Bob Ross's? Where are you, Bob Ross's? Okay. So let's see. They say what is the absolute min of this function is something when x equals something. Or how do we do this? Equity. What do you think the answers are? I'm curious. Rough start means the only way is up. I appreciate that, Jamarcus. Yeah, I do. -2? Yeah, I agree. Cool. Yeah, they're just saying, like, where's the function the least? And that's at x equals -6. I agree. So that's down here, right? Now what's the absolute max though? This is kind of this. I honestly would get this wrong. Yeah, that's the correct answer, Shantrix. There is none. I would say the absolute max is positive infinity, but I guess you're not allowed to say that, or they don't want you to say that in your class. Yeah, I say it's infinite, but I think Shantrix is right. I think you're supposed to say none, because infinity is not really a thing. It's not an it's not a real number. Yeah, I say infinity, Equity. Does your teacher say none or infinity? Because Shantrix is right. This function just keeps going up. And so this is like, we don't know when this happens. You know, it just keeps going, I guess. Yeah, Darsh says, my teacher says none. Yeah, I got humbled by that this year. Because I would have said it's infinity, but it's not. Oh, what's up, Talos? Talos is the one teaching calculus. Yes, Talos, thank you for doing that. I'm gonna make an announcement. Sorry, I've been doing wildfire bullshit, but I'm gonna make an announcement in my server this week about all the cool stuff that Penn Center said is happening, which I know you're a part of, which I really appreciate. That's cool. You started on Sunday, I think, which was fun. Yeah. Yeah, I think absolute max is none here because it just goes on forever. If this did this, the absolute min would also be none, but it stops. Whenever there's like a stop here, that's like, okay, just halt, you know. And yeah. Relative minimums. These are cool. Technically, you need calculus to really calculate where these are. But you can see them visually. And it has to do with derivatives. It's actually kind of fun. But where do we think the relative minimums are? Right, yeah, Talos is right. Yeah, infinity is not actually a defined value. It is not actually something. Yeah. So, relative minimums are going to occur here and here. Okay, so we can say at x equals -3 and +2. The way to define... I think this is the official definition for a relative minimum. Is anytime a function goes from decreasing to increasing, that defines a relative min. Yeah, you're good, Jamarcus. Yeah, you're cool. The music is kind of nice. Yeah, well, Sensation's actually the one that came up with this idea. He said, yo, you should put, like, lo-fi background music. I was like, okay, cool. I'll do it. Oh, tell me if these soundboard effects are too loud, please. I can turn them down. I noticed on the AMA they were too loud. But I'm still trying to figure out all the audio stuff. It always changes. They're good? Okay, cool. Sweet.
Nice.
They sound fine. All right, cool. Yeah, so minimums occur when a function goes from decreasing to increasing. And in calculus, which, again, I'll make an announcement. Talos is teaching a calculus class this quarter. So if you want to learn calculus, I think Talos is going to be doing that for a couple weeks, maybe the whole semester. I'll look into it. But the way we define this is that the derivative goes from negative to positive. Derivative is like the slope. It's the rate of change. So if the function is going down and then it's going up, then there must have been a minimum in between that. Usually we say this is where the derivative is equal to 0, which will occur here. So this goes from like down to up, and then there's some point where the slope is 0. Exactly. What if there's a step drop? Yeah. You're right actually. Oh, Jeff makes a good point. All the money, Jeff. But yeah, we'll go into that. That's called like a discontinuity. Absolute mins are also relative mins. Oh, this is interesting. Like, all dogs are animals, but not all animals are dogs. Oh, okay. Okay. That's actually a good point. I wonder, let us know, Equity, does your teacher also say that -6 is a relative minimum? I wonder if that is relative, because it's not going from decreasing to increasing. If anything, it's going from, like, nothing to increasing. Yeah. Oh, there's a donate button? That's cool. I didn't know we had a Stream Elements donate. There's also one just built into Twitch. Use that one. The PayPal one's easier. I think there's like a nice little bar at the top, which is fun. Oh, he calls this a relative min. Interesting. Yeah, no, we have an official nonprofit. We're official 501c3. Like, you can write off your taxes if you give money to us. You can say, if you live in the U.S. But, yeah, I need to get more aggressive on pushing that. Oh, Penn Center says it depends if an open neighborhood must include both sides of X equals A. Yeah, that is, yeah.
That's dope.
Yeah, it was a lot of paperwork to become an actual nonprofit, but yeah, we are an actual nonprofit. Because we do, I think it's called like public service. Like what's it? Generally helping the public good or something. I don't know. That's dope. Are you willing to falsify receipts? Depends how much you donate. Don't. I never knew that was a thing. Yeah, no, nonprofits are totally a thing. They enable you some cool stuff. So, for instance, Google gives us like $10,000 a month in free ad revenue. Not ad revenue, sorry, ad spend. So I can spend up to 10 grand on Google just running ads. And I actually have been. Here, I'll show it to you real quick. So, anybody else has ideas about like starting like a nonprofit or something? Yeah, if you have an official nonprofit, Google will pay for your Google AdWords stuff. So here they've given me like $1,700 for free. But what has that done? It's gotten 165 people to click on the website, which cool. I wouldn't have spent that amount, but Google's footing the bill, so go for it. Usually relative minimum must be a smallest value on X is greater than A and less than B. Yeah, exactly, Jeff, right? Yeah, that's terrible. Yeah. That's
You done messed up, AA Ron.
Yeah, that's a terrible, but I'm not paying for it. Google is, so I don't care. Oh, okay, cool. Nice. Yeah, yeah. That's what we do with TikTok and stuff. Okay. So, this is a minimum, and I think we're also saying this is a minimum. Okay. By that token, also, this is a max, and this is a max. This is not a max because it doesn't actually hit anything. So that's going to be at x equals -4 and x is equal to 1. Now, one thing that does come up here. So remember I was talking about how minimums occur when the derivative goes from decreasing to increasing. And then so somewhere in between there should be a min or a max. Usually that derivative is 0, such as here. And that happens when things are smooth. When we have like nice, smooth little things going on.
X equals -6. the absolute max. Yeah, maybe. Yeah. Nice. Someone got baby voice. We do love baby voice. Wow, thanks for the follow, man. Min. Yeah, it is. Yeah. Yes, Milos. Yeah, Milos. You submitted yours. Yeah. I'll do yours then, because you submitted yours like days ago. Can you pick which one is the hardest for you?
I know you submitted like 5, which, if you hang around long enough, I'll do all 5. But let me do like 1 or 2 of yours first, and then let me get through everyone else's questions first. Yeah. There are some weird things here, for instance, though. At this point, the derivative is not 0. It's actually undefined, because this is a very sharp point. So what happens is the slope of this function goes from being like negative to suddenly being positive just out of nowhere. And this like corner point is why we would say that it's not differentiable here. Okay, 4 and 5, cool. You finished out the first 3. Okay, cool. Yeah, just some little food for thought here. And also, by the same token, it's not differentiable here. This happens usually when you have a piecewise function. Piecewise is when we have that, right, f of x is equal to, and then it's like one of these bracket things, and there's like this for like x is between this and, I don't know, this and this. Yeah. This is kind of the only way that you get these like really sharp points, or using absolute value. Anytime you see absolute value, that's also going to cause problems. Exactly. Yes. Which is arguably piecewise. Correct. Yeah. Anyways, okay, cool. That's a good question, Equity. Good job. All right, Milos, since I got you here, and I know you asked your question days ago when I was still evacuating, so I'll help yours out. 1 sec. You need help with question 4? And then I'll go in order of everyone else who submitted. Yeah, just be patient, please. I don't have anything else to do today. Well, I should clean my apartment. I look like a fucking, I don't know, refugee or something at this point. All my stuff is in boxes all over my apartment. Ooh, the delta X? Yeah, the Dirac delta, Jamarcus. Like this. The Dirac delta function. That's a kind of a stepwise, piecewise function. Yeah. Yeah, I wonder if Pen Center... Do you use this Pen Center? Do you use Dirac delta? He's talking about... yeah, eigenfunction. Yeah, it means it's 0 everywhere except for that one position, x equals a. Will you do parametric spherical equations? Yeah, I love that. Maybe if you ask them. Okay. Wow, we have springs and charges. Ooh. Dirac delta pen. I was asking this. Do you guys use Dirac delta in math? Ace says, what time are you available? For the next hour and a half, 2 hours. Maybe 3, if I'm feeling generous. I want to raid... Someone else is streaming today. I know someone else. Yeah. So... For those that don't know, we're part of a larger community of a lot of awesome math streamers. Here's all their Twitches and stuff. And then if you ever want to check out the calendar to see when they're streaming, there's a little link there that links to a Google Calendar that Pen Center has put together for us. So, oh, never mind. That's tomorrow. So tomorrow Zach is streaming after me with Infinite Series. And then, yeah, here's Talus's calculus class, which I'll make an announcement in our Discord. But we have a lot of really awesome friends, and there's a lot of stuff happening this next couple weeks. Yeah, so Zach and Penn Center are doing a linear algebra class as well on Mondays and Wednesdays. So much fun stuff. Yeah, go eat dinner. I'll be around. Talus is still diamond armor. Okay, here, let's try and do this one Milos for you real quick. Okay, a spring with an unstrained length of 0.074 and a spring constant of this hangs vertically downwards from a ceiling. Okay, I'm gonna start drawing some stuff. I'm gonna draw this. And we're going to say unstrained, it has a length of 0.074 meters. Okay. Uniform electric field is direct vertically upwards. Okay, so we have an E field. I'm going to put in blue. There's an E field pointing up. And fills a region contain a sphere of mass this. Ooh, look, Jeff, it's your favorite sphere. Jeff loves all things circular, including arguments. Here's the sphere, which that has a mass of 5.1 times 10 to the minus 3 kilograms. Cool. And it has a net charge. Wait, which Jeff? You're the spherical Jeff. 10 to the minus 6 coulombs. Okay. The spring is released slowly until it reaches an equilibrium length of 0.059. Oh, interesting. So... it's released, and then this thing actually moves up, right? Because now the length is actually less. Okay. What is the magnitude of the external electric field? Okay. Kind of tricky here, because I think we have to consider a couple situations here. So they say, when they say unstrained, I assume that means that without the mass on it either. I think that's just the spring just chilling, okay? So the first thing I want to figure out is really what the... well, actually, I can account for that, can't I? Yes, I can. Never mind. I was going to figure out what the length of it was with the mass and no electric field, like the amount that gravity pulls it down. And then I was going to use that as my delta X. But we can account for everything all at once. Okay. So actually, this is it with nothing attached. And then what we're saying is that when there is something attached, that it moves up a little bit. Namely, this moves up to... Okay, let's draw like a little bit less. It moves up to 0.059. So less of a stretch. Okay, cool. And let's put this over here. All right, cool. All right, so what we're going to do is we're going to draw out like what the forces are on this thing. Okay. So if we look at the ball, you have the force of gravity, which is pulling down. And that's equal to mg. So that's going to be our 5.1 times 10 to the minus 3. And then there's going to be times 9.8. Okay. And then we also have the electric field. Now, because this thing is moving up, like it's a shorter distance, that tells me that the electric field force must be pointing up. Okay. Because the only other force, right, the spring force, wants to keep things at this equilibrium. So I assume it's pushing it down, is what it is. So let's see. Yeah, so since this distance is less than the equilibrium distance, that tells me that the spring force is actually... the spring force, by Hooke's law, always opposes the direction something is moving relative to the equilibrium. Because in equilibrium, the spring wanted to be this long, and now the spring is shorter, that means the spring is going to push down. So we have an additional force here of F is equal to Kx, which in that case, that's the K here, which is 2.4. And now X is the distance from equilibrium, which is this minus this. So that's 0.015. Okay, cool. That's that force. And then my last bit of force is going to be from the electric field. So anytime you have a charged particle in an electric field, that produces a force. And that here is going to be Fe, which is Q times E, which is equal to this 6.6 times 10 to the minus 6 times whatever the electric field is. All right. And then we know it's at equilibrium. At equilibrium means the acceleration is 0. So sum of forces, which equals m times a, this is 0. So we just need all the forces to kind of like cancel each other out. So that means all the up forces need to equal the sum of all the down forces. So you get 6.6 times 10 to the minus 6. What's up, Recky Rec? Times E is equal to the 2.4 times the 0.015. I think that's what it was, right? Yeah, 2.4, 0.015. Plus this one, which is also pulling down, which is the 5.1 times 10 to the minus 3 times 9.8. Okay. At this point, this is just algebra, right? We're just solving for E. So, where's my calculator? Oh, there you are. Okay, one second. Let me pull this up. Cool. Calculadora. There you are. Okay, so 2.4 times 0.015 is that, plus 5.1 e the negative 3. Let's put this in here. Times 9.8. Cool. That's everything on the right. And then we're going to divide this by 6.6 e to the minus 6. And that's going to get us an electric field, of quite a lot. But that's an electric field of 13027. And then here we can use sig figs. It's really only 2 sig figs from this, right? This is only 2 sig figs. So really you could just say this. It's 13,000. Is it newtons per meter? I think it's newtons per meter, right? Q times F equals QE. Oh, it's Newton per Coulomb. That's what it is. Yeah, newtons per Coulomb. Okay, cool. Yeah. That's the answer for that one. What's up, Joffrey? How's it going? Joffrey asks, I'm taking applied calc as a 7-week class. I'm going to get an A. I did well on my position, velocity, acceleration assignment, but it doesn't make intuitive sense, man. Oh, okay. That's all good. If you have an example homework question, I can through it and try to help it make sense. Just join our Discord and post a screenshot. Also, I keep drawing pictures of cats in my assignments because I'm weird like that. It's okay. I used to draw pictures of lots of weird things on my assignments. But yeah. Yo, what's up, Swaz? And Milosh. Okay. Milos, does that make here? Let me see if I can start streaming again on. Yeah, come on up, Swaz. Let me see if I can start streaming again on Discord. No, well. Yeah. What's going on, Swaz? Yeah,
What's up, dude?
What's up? Just. Are you in North Carolina? I forget. Where are you at? Where are you at?
Yeah, I'm in North Carolina.
Oh, okay, cool. Wait, are you okay? Isn't like North Carolina freezing its tits off right now or something?
I mean, it's cold. Yeah, it's pretty cold.
It's pretty cold. It's pretty cold.
I'm by the beach though, so the beach is keeping us warm.
Nice. That's good.
Yeah.
Yeah, I would say it's pretty hot here in LA because it keeps like burning. But
Oh yeah, no, that's not it.
we're both in like two like disaster states at this point in time.
Mine's fine, bro. I'm chilling.
I'm chilling, dude. Let me see. Milo, should that make sense to you for number 4? Let us know. Yeah, this makes sense. Most confusing part was setting up the questions and assuming if the ball was on or off the spring. Agreed, Milosh. Yeah, dude. Here the ball was off the spring. Here the ball was on. And so once the ball is on, you have to use this difference in the distance as delta x. That's the tricky part. But yeah, glad you got that. Let me see. I think you need help with number 5 too. Let me just do number 5. Swaz, what's up? Have you started school yet, dude?
Me? Yeah, no, I'm back at it. I'm second semester senior though,
Oh,
so I'm not doing
just fucking
shit,
chilling,
dude.
Yeah, he's like,
Yeah.
what is it called? Senioritis, right?
Yeah, but I'm just doing my homework, dude, and then I'm not studying for any more tests or anything.
Okay. Well,
I'm
you
just
should
passing.
I'm just passing. Dude. Did you get any college acceptances yet?
Yeah, I'm Charlotte and ECU. I'm just waiting to hear back from NC State, but I hear back
Nice.
30th
Congrats, dude.
this month.
The boy's going to college, dude. He's going to college. Nice. Dun, dun. Well, I mean, are you taking any AP classes, Swaz?
Yeah, I'm taking like 3 this year.
Oh, get credit for those, dog. Like, at least study for
Oh, yeah, no,
those.
those are the only ones I care about.
Yeah, yeah. Because college credit, dude, will save you out of so much shit, dude. Like, it'll help your parents out with money and stuff. And then you can go
Yeah,
buy
for
more weed
sure.
or whatever you want, you know? I don't care.
Oh my dude, my card just ran out.
I don't know, dude. I don't know how you guys do it. I can't think or do anything.
I can't either, bro. I'm just about to fall asleep. Bro, I'm about to fall asleep, dude. I went to the gym today.
I need to go to the gym. I need to go to the gym today myself.
Oh my god. Today I hit back and chest.
Back and chest? That's an interesting combo.
Yeah.
Isn't it usually chest and
It's kinda-
triceps?
Yeah, chest and triceps, yeah. But I did triceps and biceps yesterday, so I was like,
Oh, you do
let's
like
do-
arms. Well, yeah,
yeah,
that's
I
not
solo
push-pull.
my arms, but
You solo
yeah,
your
yeah,
arms. Okay, gotcha.
I solo my arms, but I also like to do biceps just or a little bit of biceps, just 'cause I like looking at the pump in the mirror.
Yeah, it's called the glory muscles and stuff, dude.
Dude,
What's up, Roy?
I started an Instagram to track like all my.
Did you?
Shit.
Yeah, go follow me. Send me your Instagram. Yeah. You can see the uncensored form of me, which this is already pretty uncensored.
Dude, oh my god, piss me off.
Yeah, you're good. One sec. Let me tell Joffrey. Here, Joffrey, if you want to join our Discord, by the way, sorry for those watching on YouTube. On YouTube, yeah, that's the Discord. Just join that Discord, and then there's a channel right here called Help Screenshots, and that's where we're helping students from. So if you post a screenshot in here, I will go over it today. I have no other students to teach today. I just want to go to the gym at some point, but that doesn't close for another, 6 hours? So we're okay.
What time is it for you?
3:50.
Bro.
Yeah, it's late for you. What, 6:50?
Almost 7. Yeah, it's almost 7 for me.
It's
Yeah.
like it's almost dinner time. I woke up at noon today.
I
I was
know.
I was teaching a kid in Israel last night till 4 a.m.
What?
Yeah, he had like a because of the time difference. It's a 10-hour time difference. So he wanted to meet at noon, his time, which is 2 a.m. my time. Luckily, I was still awake. But
Can
yeah,
he meet at like? Why couldn't he meet at like 7? You would have been up by then.
No, because
Really
well, I don't
late
wake
in
up.
the
I don't wake up at 7 a.m. I don't do that.
You know?
No, I don't do that. No.
No, I'm saying like meet at like 7 his time.
Yeah, 7
know?
p.m. his 7 p.m. his time would have been 5 a.m. my time. I wasn't waking up at 5
Oh
a.m.
fuck.
Yeah, not doing that.
Yeah, no, maybe not. Maybe not.
Teaching to 4 a.m. is dedication. Yeah. Well, also I need money because rent isn't free. That's why I teach till 4 a.m. Yeah. The nice dedication part is helping the kids out for free here. The teaching till 4 a.m. is because I have to pay rent. That's a bitch. All right, massive charge of particle 1. Here we go. Ooh, we got some masses. Let's do this. Let's do this, Milosh. This is cool. This would maybe actually be the course I would teach next quarter. It would be E&M physics, which is my favorite. This is actually what got me into physics. That's what I'm taking. Yeah, dude. E&M is great, dude. Microcoulombs, 10 to the minus 6. Some kids don't like it because it doesn't. It's you can't visualize it. It's not real. The concept of electric fields and charges, you don't. It's much easier to conceptualize. Oh, there's a ball, and I throw the ball up, and then the ball hits like the fence or something. But the charge moves this much. It's kind of harder for students to grasp, I guess.
It should.
Yo. Initially the particles are at rest. The particles are both located on the same electric field line but are separated each other by distance d. Okay, cool. So that tells us that there's an electric field going this way. Okay, and then there's a distance. I'm looking with no. This is cool, Jamarcus. We like this stuff. Particle 1 is the left from d. Cool. When released, they accelerate but always remain at the same distance from each other. Sorry, what? How? Oh. Ooh. Oh, this is super weird. Oh, wow. Okay. It's like a relativity question. Because, what's up, anti-caffeine? So let's think about this. These two things, have opposite charges? Right. Okay, they have opposite charges. So these two things want to get closer to each other. Opposites attract, right? So this is negative and this is positive. This wants to move towards this and this wants to move towards this. What we learn, right, is that F is equal to K Q1 Q2 over R squared. So this is the force that one of the charges feels because of the other charge. And it turns out whatever the force this one feels from this one is the same force that this one feels from this one. And they're going towards each other. However, we need the distance between these two things to stay the same. So if this is positive and this is negative and they want to move towards each other, that means I need an electric field that points in this direction. This is actually pretty cool because this will cause the positive charge, like this would be the force of the electric field, to move to the right. And it would cause this one to move to the left. Because F is equal to QE. F is always equal to QE. So in this case, Q is negative. So the electric field is positive, it points to the right. So the force is negative. So the electric field pulls this one to the left. Whereas the force from the charge, let's call this 1 and let's call this 2. There's a force here. I'm going to say F2 on 1. So this is the force on charge 1 because charge 2 is trying to pull it. And in order for this distance to stay the same, we need these two forces to cancel each other out. Because that means then that there's no acceleration. And if there is no acceleration, it means it's in equilibrium. So it's not really moving. Or if it is moving, they're moving at a constant speed. And it turns out, right, this is actually kind of cool. This is F1 on 2. And these forces are equal. But interesting enough, these forces won't be equal, right? Or we need them to not be equal. Oh, man. Oh, actually, I think I get this now. I need the acceleration of both of these objects to be the same. I think that's what I need. Yeah, it's not that I need the forces to cancel out, because they won't. This force is the same as this. But this is QE. And since the Q's are different, E is constant. Even if I get this equal to 0. What's up, Seth? Thanks, man. Yeah, I'm doing okay. Surviving. Yeah, that's super cool. This is a really tricky question, Milos, actually. This is very interesting. Because my gut instinct would be to have these forces equal to each other, but then these won't be. Do you understand why that is, Milos? Why, like, even if I get these to sum to 0, that these can't sum to 0? Man, wow, what a clusterfuck of a question. Okay, so this is what I need. I need A1 to equal A2. And then let's remember that F equals MA. So A1 is going to equal to F net 1 over M1. Okay. So let's go through what that's going to be. So let's do F net for the first one. And then we have the M1s on each case. I'm going to keep everything as variables for now because things may cancel, which would be really nice. Okay. So F net. So we have F21. So that's going to be K, Q1, Q2 over R squared, which is going to be D squared. Okay. I don't think they give us D either, right? Yeah, they just say it's some distance. Okay, it's probably going to cancel. We're going to see. So F net is equal to F21 minus FE. So that's that minus, and then that's going to be Q1E. And that all over M1. Oh, it says find D? Oh, I thought it said find E. Oh, they give us E. Thank you. Okay, cool. What's the essay, Jamarcus? What do you got? Okay, so this is F net 1 over M1 is equal to that, which is equal to A1. Oh, yeah, send it to me. I'd like to see it. Okay, then F net 2, again, K, Q1, Q2, all over D squared. But this is now in the minus direction because this force... So now this is F net is equal to FE minus F12. So honestly, you guys have ChatGPT these days. It's so nice to be able to write essays, like to help yourself. Don't use it to just write the whole essay. Don't do that.
No. That's what I did for my college apps, man.
I definitely used it to help augment essays. So students would, for instance, send me what they thought they wanted to write, and then I would use ChatGPT selectively in certain sentences or paragraphs to help me to be, okay, I want to combine these two ideas. Can you combine these two sentences into one? Or, you know, what's a better way to say this? Because I have like the ideas sometimes, but there's this mental roadblock of, wait, but how do I say it? And ChatGPT at least gives you options. And you're like, oh, I didn't think to use that word. Yeah, it's pretty cool. You just got to make sure it doesn't sound too fake. All right, there we go. Because like ChatGPT loves using the word such as deepened my passions. Like there's certain keywords that it keeps using over and over again that I say, bro, this is like too much. Okay, and then this is over here. Let's put this over here. Okay, and then this is FE, so then this is Q2E. Wow. Okay. I need all of this to be solved. Jesus Christ. Well, the nice thing here... Yeah, this is super yuck, dude. Yeah, this is gross. What the fuck is this, dude? Yeah, nothing cancels, unfortunately.
What the fuck is this piece of shit?
Yeah, so I think I know I'm isolating for D at least, right? So let's cross multiply the M1s and the M2s. So K, Q1, Q2, M1 over D squared minus, oh sorry, that's M2, not M1. Minus Q1 M2E is equal to Q2 M1E minus K Q1 Q2 M1 all over D squared. These are the things I want to solve. So little key trick, guys. Whenever you figure out the variable you're trying to isolate, just get that thing, any term that has that, on one side. Put everything else on the other side. So I'm gonna take this, for instance, and move it over here. So here, let me copy paste this so we have some room to work with. So this I'm gonna add over here. And this I'm going to add over here. So let's do it. Okay, so this is going to come over here. And let's not forget the d squared. It's going to be kind of nice. Yeah, right? Because I at least have some common terms here. And then this we're going to put over here. Because also, I have all these variables, right? I have Q1, I have Q2, I have M1, I have M2, I have E. But this is why it's important to try to keep things in terms of variables first, so that you're not running around fucking up decimal places or something. You don't want to do that. Okay, because the nice thing here is now I can pull out d squared from each thing. Oh, 1 over d squared. So I'm going to say 1 over d squared. And then we have this. Plus this. Equals all of this. And now I can move this over here and move this underneath here. Wow. Exactly.
Dr. Gold, once you finish with that problem, did I ask you a question?
Yeah, you can ask me a question, dude. You're good.
Alright.
Is it like a math question I gotta solve or what?
Yeah.
Okay, is it quick? Because it's quite a lot.
Well, it's not a question. It's just like a clarifying question.
Oh yeah, you can. Yeah, that's fine. Yeah.
Wait, what is it? What is a parameter in stats? I'm confused.
Parameter is such as standard deviation, mean, I don't know. Yeah, mean, standard deviation, like one of those things.
Okay.
What you mean, like a parameter in a study?
Yeah. You want me
like
to stream real quick, and I can just show you real quick.
Just drop me a screenshot in this chat real quick. Just drop it in the chat here. I'll check.
Oh fuck! I gotta remember how to.
Command Shift S, or Windows Shift S will bring up the snipping tool. Square root fun, yes, and then square root. Thank you, Seth. Yes, the last little bit here. Oh, what's my Discord? It's right here. Whatever this one is, should work because Laz bought us tier 3. Thank you, Laz. Why did I use like... Parameter is a characteristic that describes the population. Okay. So that would be Joffrey, yeah. Something like standard deviation or mean or whatever. Or population mean. Yeah. Yes, that works. Yeah, that one works too. Yeah, just exclamation point Discord works. Yeah. Maybe I should have linked to it too. Okay. Yeah, that one works as well. That's a hard link. That always works. Okay, I'm going to copy this down here because I need all this information now. Okay. We're almost done here, Milos. Now, does this make sense, Milos? Like, the setup is the hard part, and then the algebra just sucks. But okay. K is 99. And then, you know, actually, I'm gonna assign variables to things. So you can do this in the calculator if you want to see. This is a pretty cool thing on the TI-84. You can assign variables to things. So I can say E, in this case, is equal to 2500. Or actually, no, sorry. I have to say 2500 is equal to E. Yeah. You hit store here, and you say E, and now that variable E is always 2500. Oh, mobile doesn't like it? Oh, weird. Nice, 7 stream streak. Good job. And then here, I'm going to say that M1 is M. So I'm going to call that, so 1.4 e the negative 5. We're going to store that as M. And then I'm going to say M2 is N. So I'm going to say, where is M2? So 2.6 e negative 5 is equal to N. Cool. And then Q1, I'll store as Q. So I'll say negative 7 e the minus 6 is equal to Q. And then I'll have R be Q2. So I'll say 18 e the negative 6. Oh, and actually, I don't want to make those negative. Because this is a tricky thing in physics. Because I already assumed the direction was negative here, I really should have put a plus here, and then that would have Yeah. I see. Yeah. We assumed the sign when I said that this was positive, pulling it to the right, and that this was negative, pulling it to the left. So actually, you have to make sure when plugging back in here, all your Q's are positive. Yeah, it's a little thing it's tricky though. You got to be careful with that in physics. You can either keep everything positive and then have the numbers be negative when you plug them in, or you can say all the charges and everything is positive and that you're dealing with the negative in terms of the directions when you write out your sum of forces. Yeah, it's that used to also mess me up a lot in class. So I understand. So, okay, 18E minus 6, that's going to be equal to R. Okay, sweet. All right, now we're done. Okay, so watch what I do here. Oh, and then did I say 99 was equal to K? No, I need to do that as well. Okay, one sec. And then K, which is Coulomb's constant or whatever it is. 9E9 implies K. Okay, so now when I do this, so we're going to do K. Watch what we do here. I'm going to say K, Q1, Q2 is R, M1, which is just M, plus K. Oh, I realized I could have actually simplified this. Yeah, but whatever. I'll do it for you guys. Q1, Q2, M2, which is now N. That's that. And then we're going to divide this by Q2, which is R, M1, which is M, and E. I could have made this a little bit more simple algebraically, but that's okay. Q, N, E. Okay, cool. That gets me that answer. And then I'm going to square root that whole thing. And that's going to give me a distance of 6.47 meters. Seems a little bit big. I'll admit, 4 meters is pretty big. What's up, Ricky? Okay. So I may have something wrong with the calculator. I don't like 4 meters. That's very big. Yeah, right, Seth? But the process is correct. My answer is off. Seth, do you know what the answer is? What's wrong with my answer? Based on the calculator, it is 6. Oh. Oh, sorry, dude. Yeah, what am I saying, bro? Oh, thank you. Yeah, oh my god. It's 6.47. Why did I say 4.47? I don't know. I wanted it to be lower. Okay, yeah. Nice save there, by the way. Thank you for catching that. Anyways. What's up, QV? Good to see you, bro. Long time no see. Okay, so, Milos, that's how you do this one. There may be something wrong with the algebra, but just let me know. I hope that at least helps you with that part. Yeah. Cool. And yeah, let me know if you need help with that stuff, but that's the general strat. Nice? Okay, cool. Awesome. Great. Okay. Adarsh. That kind of makes sense. It just seems like there's too much info in the question. Thank you, appreciate it. Yeah, there actually was the right amount of information. We needed all that information they gave to us to solve this one. But yeah. Sum of forces. Set the accelerations equal to each other and it works out. Okay. What's up? I'm gonna post Darsh's question, but what's up, Swaz? What do you have a screenshot of like what you need help with?
Oh no! When y'all were talking about it earlier, help me.
All right, cool, dude. What's up, Ethan?
I'm here.
How's it going, bro? How's it going, dog?
It's going all right.
Nice, dude. You got a test coming up tomorrow, you said?
No, just a little homework.
Okay. Cool. You posted
Oh.
it. You're soon. I gotta do Reki Rex, and then you're next.
Yeah,
Ooh, 18
Yeah,
caffeine
the
has a
one
question.
thing
What's
is,
the main thing?
I got back my physics teacher, my other physics teacher. I had a new one, but the other one
Okay.
came back.
Okay. Is it a better teacher than what you had, or a worse teacher?
A little better, yeah.
Nice.
I like
Yeah,
both
we like
teachers.
that. We like that. Big fans of that. Okay,
Yeah,
let me see.
it's like. It's
What's
like
up? What's up,
now
Ethan?
it's just to pass the class now, and I'm
No.
getting my report for next week.
No, we're gonna get you an A in the class, dude. You're not just passing, dude. You're gonna get an A. Come on, dog.
I read that.
You're smart. You can
Well,
do it, dude. I know you can.
you know, well, next week I'm also getting my report card,
Mm-hmm.
and I'm
You know-
kind of a little nervous.
It's okay. You had almost all A's last time, right?
Mm-hmm.
Yeah. I believe you. You can do it, dude.
I want to get first,
Yes.
Yes.
First place.
but it's kind of close then.
Ah, yeah. That's okay. Go for it. Adarsh, how do I do this one? What do I do for this one, Adarsh? I wanna move these through these so I can help out Ethan and stuff. Dude, what's with all the caps, dog? I can still get that bond coin. Yeah, just ask a question. You can't stay for yours is next, dude. It's literally next. We have to go through Adarsh's real quick. Yeah. Just chill. Just wait. It'll take like 2 minutes. Anyways, here, I'll do this one real quick. Okay. So, this exponent needs to distribute to both. And let's remember, if we have an exponent, like exponent to an exponent, it's the same thing as exponents multiply. Wow, you already have the Seth already did it. Let's see. Okay, watch. Let's distribute the 2. And the 2 doesn't go to the 3. So we have 3. And then it's x to the 1/2 times 2. So that's x to the 1. Y to the 6th. Minus. And then this is going to become x to the 3 times the 3rd. That's just to the 1. 18 to the 1/3. That's to the 6. Y to the 6. Oh, that's nice. See how these are the same formats, right? 3x y to the 6 minus x y to the 6. So that's 3x y to the 6's minus 1x y to the 6's, which is 2x y to the 6's. Yeah. Yeah, nice. Good job, Seth. Yeah, you can say you're next, Reki. Okay, cool. Yeah, this is easy. Now, where this would have been tricky though is if they had switched this. Let's say, for instance, this was like x squared. Now you can't combine these. You can only combine things that are the same in terms of the variables. And then the numbers can just do whatever. Right? This is like 3 minus 1. That's cool. That's how we got 2. But you need to make sure that all of these terms that it's attached to are the same. Okay, cool. Yeah, good job, Darsh. Nice. Reki, you're up.
Well done! Well
Thanks for the follow, Muchi Marana. Muchi Marana. Okay. All right, Reki, here we go. Looks like a stats question. Canadian cities. Ooh, I know some of these. I've been to some of these cities. I'm gonna go in an intermediate algebra deep dive later. Nice. Yeah, dive in, dude. I think Penn Center's doing a linear algebra course starting next week. That'll be fun. Okay. Yeah, linear algebra is really cool. It's the one thing I need to like practice. Honestly, I might like come to some of his classes. With Zach. Oh wow, yeah, dude. I love Zach. Zach's a great guy too. We love all those guys. Describe the distribution of the data in 1996, 1999, and 2000. Then compare the 3 data sets. Interesting.
Is that the goal? I just realized something.
What's up, dude?
Are you supposed to share your screen?
Am I not sharing it on Discord?
Not on Discord, to me at least. I don't know.
Oh, let me do that. I'm sorry, dude. Oh, I think because it was breaking
I'll
my
be right
frame
back.
rates. Are you good, dude?
It was when?
It was breaking my frame rates, is what it was doing.
Oh. Alright.
Let me see. Maybe I can start doing it again. No, I'm already yeah, it's getting mad at me. One sec, yeah. I don't know. OBS is having a hard time right now with Discord for some reason. Normal are they normal? Yeah, I mean, is this normally distributed? Then compare. So they say the 3 data sets. So I assume they're meaning compare 1996 to 1998 to 2000. Yeah. So actually, this is really cool. I'm going to use ChatGPT for this because I don't want to type this in by hand because this would suck. I'm going to show you how to do it. All right. So I'm going to go ChatGPT. And I'm going to say, hey, man, can you convert this data into a spreadsheet? And it's going to do it. This is where, like, AI is cool. Because otherwise, doing this on the stream would fucking suck. It would take so much time. I'm pretty sure it can do it. Yeah, here. Cool. Now we got a spreadsheet. Love it. It's an XLS file. Fine. One sec. Let me pull up my Google Drive and upload it. I don't want you guys to see everything in my Google Drive. Yeah, 3 years ago? Stats is cool, man. I really like stats. Okay, here we go. We got the data. Look at that. Bless you, ChatGPT. Just did it right like that, okay? So, I can do some statistics on this. Really, I think I'd like to just graph this. Let's see if we can just graph it. I know how to do this on a TI-84. I gotta remember how to do this on this. I think I take this and I say insert chart. But that's not the type of chart I want. I want a histogram. Does it do histograms? I forget. A scatter chart? No. I gotta remember how to do this in Google Sheets. I know how to do this in I want a histogram. What's it? Where's a histogram? Do they not have histograms in this? That's awful if they don't. Oh, yeah, I hit select chart type. Yeah, but like, where's histogram? Like, I don't have to manually bin this. Ew. One sec. I gotta Google this for a second. I would think so too, right? Histogram. Oh, scroll down to other, click histogram. Okay, cool, got it. That's what I need to do. Okay, one sec. It's in the other column. That's it. There we go. Love it. Okay, cool. And then I can customize bucket size is auto. I don't want that. Whatever, let's keep it as auto. That's okay. Okay. So this doesn't look very normally distributed. Normal distribution should be like center and then to left and right. I just shorted my 790 SA to 465. Nice, dude. Yeah, you do. That or you need to know one of the things like SPSS or something. So I think I can like insert another series here. One sec. I think I can do this. Data range. Yeah, here. This is very cool. You can do add series. And then you can select this column. Puts another column in there. And then you can add another series, which is really cool. You can do this. Okay. I would say that the red series, which is 1998, that's probably the most normally distributed. 1998 is the most. I see kind of like a bell curve with it. Whereas green is almost like a uniform distribution. You see how like we're kind of all the same? And then blue is not normally distributed either. But what I would say is that I believe the average of green is higher than the average of red, which is higher than the average of blue. Yeah, that's what I use to describe it. Yeah. It would be cool if there's like a skew or like some outliers. And yeah, green has none lower than 130,000. Yeah. So if you wanted to do this is actually I can do this. So we can see here. Let's say mean standard deviation, because I know how to do this. So this is a function. You say equals, and then you're gonna say average. This is so cool. Google Sheets already knows what I'm gonna do here. I just literally hit tab, and it'll do it. Really, back in the day, you would have to like type in average. See what I'm saying here? Like, watch. I can just hit equals. Do you see how it automatically knows I want to do a standard deviation? I didn't even type in stdev. It just does it. So cool. There you go. So yes, yeah, it's pretty freaky. Like it read this and it knew I was gonna do. This is some AI shit. That's what this is doing. So the standard deviations are all about the same. So that tells me that the variation in prices is the same between 96, 98, and 2000. However, the price is going up. I would also say that, here, let me move these over. I want to paste special, paste values only. Because otherwise it's going to count these as data points. But I would say that the shape of the distribution went from not normal to normal to normal. Yeah. So cool. Yeah, Reki, that's what I would say. You can talk about this if you want. Nice. Okay. Good question, dude. Yeah, that's how to use technology, dude. That's why AI is helpful. Because that would have taken me a lot longer to manually input this data by hand and then to do these calculations by hand. What was part B? Why might a comparison to the 3 data sets be useful? This is where statistics is such like an open thing. Like what? It could be useful to see what the trend of housing prices are over the years. That's what I would say. So you can tell that the price of housing in Canada is going up. No surprise. Exactly. It's not a replacement for your brain. It's only as useful as the user. Correct. What's up, Obi? Yeah, shout out to Obi. What's up, Obi? Good to see you, dude. Or not. Yeah, and yeah, sorry. You are Obi. Dude, my brain these days. I do not like this question much. It should have given you this Excel chart. I mean, IRL people would do the same thing as you did. Input data to Excel to better visualize it. Agree. Yeah, when I see this, I can't see what the average is. I really can't. I have to put it into a spreadsheet, and then I have to have Excel do the numbers for me. But yeah, Obi is so true about AI is only as good as the user. It's the same thing as this calculator, right? This calculator makes a lot of things not as tedious. Like it's a lot easier to do math with a calculator, but you still have to know how to do math. It's the same thing, you know, if you give a Porsche to a newborn baby, but you give a Civic to an adult, who's going to make it around the racetrack easier in a faster time? Well, it's going to be the adult with the Honda Civic. So even though the Civic is a slower car, they at least know how to use it, versus a baby who probably can't even reach the pedals.
You done messed up, Aaron!
So yeah, you still got to learn math, but technology is cool to speed things up once you know how to do it. Yeah. All right, cool. All right, Ethan, what's up? You want to do your question? Some physics? Who's going to crash faster? Probably the baby, dude.
But you can't share your screen still yet?
Let me try. Yeah, it's just... Yeah, Discord's just being really weird with frame rates today. Okay, can you see that at least? It's
Yeah,
not my full. It's not my full stream, but it's because I think OBS and Discord are not playing nice today. All right, good to see you, Reki. If I was a teacher, my question would be: show me how would you use Excel to visualize this? I agree, Moochie. Yeah, because just telling someone, "Hey, what do you think about this data?" doesn't really point them in the right direction of, "Hey, you're supposed to use tech to visualize this." Because you can't do it by hand. You could plot it by hand, but bro, that would suck. Don't want to do that. Okay. In an experiment to verify a gas law, the following data... okay, cool. Copy the table. You just need part D to help, right? You just need this?
Yeah, just
part
part D, because part A, B, and C are just the same. They're just okay.
Right, yeah. You know how to convert from centigrade to Kelvin, plot a graph, cool, calculate the... Do you know what the gradient is?
it's like if I can remember correctly, I think it was I got to 1.2 when K/MQ the rule is similar way. It
Yeah,
was
it's
always Y/.
it's the slope. It's the slope between points, right? This is called the slope.
It's also called a slope, yeah, or the steepness.
Yeah, and really, you could calculate the gradient between like a couple of these points, but you probably just did the lowest one and the biggest one. Is that what you did?
Well, I took 2 different points. That's what the teacher wants us to do, I believe.
Oh, okay.
But even if I did take those highest and lowest points, it would approximately give me the same answer.
It should, right? Yeah. Why is that, Ethan? Why does it give you the same value?
Because they're like
question.
2 separate points. They're like not that close to each other or something.
It's because they're linear. So do you remember what the gas law is?
Gas
Inside.
law. PV is a PV is equal to nRT.
Yeah, it's good. PV equals nRT. Okay.
Yes.
It is 273. Yeah, that is it. Okay. So if things are held constant, so let's say for instance we held this constant. Yeah. Well, the gradient versus Kelvin. Well, actually, no. Versus centigrade is still fine. Obi, because it's linear. And it's just multiples. If I think if we start adding stuff gets weird. So if you hold these all constant, if you hold n, r, and whatever, okay. Do you see how you just have v is equal to nRT over p? And so this looks like some constant, which we usually say is like alpha, okay? So I would say v is equal to alpha t. This is called being directly proportional, which means if,
Wait,
for instance, the volume goes up, so does the
CX
temperature.
thing. I really do not understand that CX thing.
Oh, this is an alpha. Alpha, sorry. It's a symbol. It looks like a fishy.
Yeah.
Cool.
Well, yeah, I see that, but it's like when does that show up?
So what I'm doing here, Ethan, is, and honestly, like, fuck alpha, whatever. I can call it C if I want, whatever. Let's call it C, because alpha's kind of weird. So C, this just means this is a constant. A Greek Socrates moment, yeah. So this means that it doesn't change as these things change, right? Okay. Okay. So yeah, because this looks like a linear equation looks something like this, right? Remember y is equal to mx plus b? This is called linear. Yeah. When things are linear, when things are linear, the slope is constant. Right? This is a line linear. It means whatever the slope is here is the same as the slope is here, is the same as the slope is here. Oh wow, thanks for the follow, dude. That one OG-chan. Okay.
Yes.
So what factors should be controlled? Okay. So in doing this experiment, right, if you just want to compare volume to temperature, you need all of these things to stay the same. They need to be constant, which is the same thing as saying they need to be controlled.
So it's just the number of molecules, right?
Good. Number of molecules. And what else?
Pressure as well.
And the pressure, yeah. Yeah.
Wait, what about R though? Or wait, is that
R,
undefined?
R is just a number. R is already a constant. You don't have to keep R constant. R is constant for free.
So volume and pressure, that's it?
No, not volume and pressure. Number of particles, N.
Oh yeah.
Which I think this is number of moles. No, I think this is number of particles.
No wait. Hold on. It's like search it up at least.
Yeah, one sec.
EV is equal to nR.
No, N is the number of moles. Okay, sorry. I'm thinking about big N.
Okay.
That's when it's big N, NKT. So yeah, number of moles.
See, it says there R is a universal gas constant.
Yeah. That thing doesn't change.
Alright, so just pressure and the number of moles.
Yeah. Cool.
Alright.
Nice.
Got it.
Nice. Okay, good job, dude. If you have more questions, right, about your physics test coming up, just drop them in the chat or something, and I'll go through them later. You know, want to make sure you do well on your test.
But that's one thing. if I were to take the highest number and the lowest number from the table, I would get like 1.19 compared to the 1.2. It's kind of
Oh, okay, okay, I see.
It's kind of similar. It's kind of the same, but not. It's close though.
It's close. Yeah. The slope would not be as precise. Oh, interesting, Seth. Yeah. So in reality, data is never perfect, but it may look something like this. You may have like data points that are like just chilling out, like doing this. Okay, but they're gonna be mostly close.
See, like when I was drawing the line for that graph, majority of the points were connecting, but I think the fourth one that says 14 and 75. I think that one was that was the one that was way disconnected from the line.
This one was really disconnected. Yeah, you're gonna have outliers every once in a while.
And that just made me rethink.
I see it.
If I even did it correctly. But I'm just in my gut.
Okay.
Is there any websites out there that can plot the graph automatically for you?
I mean, yeah,
Or
there's
I can test it
ChatGPT.
out? Not ChatGPT. That I don't think like any online website.
Seth says Desmos. I think Desmos will plot things.
Desmos?
Yeah, here. You can do this. Again, I can use ChatGPT to what is this like? Let's see. Give me this as a table.
What? A table?
It's just gonna give me the number so I don't have to transcribe it. Oh, interesting. Well, that's a weird form. Give this in a form of points I can plot on Desmos. I don't know. Maybe it'll do it. Let's just see. Graphing calculator. I think I want to do a table. Yeah, here we go. ChatGPT, did you do it? Okay. Will this maybe work?
I don't think it will.
Yeah, it's a grad student, dude. It's a grad student. Yeah, you have to do it one by one. Is there not a way to just copy paste it in? I really don't want to do that.
I guess that's the only option really.
So sheet. Dude, that's super annoying.
Yeah, I understand, but
one sec. I think I might get it this way.
hopefully.
Okay, here, let's download the spreadsheet. I'm just curious. And then let me... One sec. I gotta put this into... I'm just curious. If I can do this easily. Okay, here we go. I think I can just copy this in. Copy. Where's Desmos again? What? Oh, did I lose Desmos already? Bingo! There we go. Yeah, there you go. That's how you do it. Yeah, you just have to get it in column form. And then, yeah, here's the points. Mm-hmm.
I did not kind of get it. Wait, you got the wrong one. It was supposed to be a volume versus Kelvin, right? It's in degrees Celsius.
Oh, yeah, whatever. Yeah, okay. You just add 273 to all these. Yeah, that's not too hard.
Then.
Yeah, you could take these if you want. Equals this one. Was it plus 273? Yeah. There we go. Okay. There you go. Okay. This should work. Oh, okay. That's cool. There you go. That's volume in Kelvin.
Yeah, okay. So see, I kind of get that.
I see how this data point right here messes things up, right?
It messed me up a little bit and made me think if I did this correctly.
There's a line formula as well. Yeah, there might be. I think you can ask ChatGPT to give me the Well, linear regression. Okay, wait one second. Add 273 to every y value. That point. And then I can tell it to actually figure it out. It's actually pretty cool.
Wait, that to go. There is one thing. If I compare that graph online to my graph, I have the off points like above instead of below.
Oh, it's volume versus temperature. Oh, okay. You gotta swap them. That's annoying.
Oh.
Sorry. It's volume versus temperature. So it's y versus x. Okay, cool. Whatever.
Yeah. Wait, you got that mixed up?
Yeah, I did. I thought it was temperature versus.
Hey.
It's okay.
Nah, it's volume versus Kelvin temperature.
Okay, it's this. Oh, you
Oh
sent me
yeah,
it?
it's kind of the same thing. Yeah, see, if you can compare that to mine's, it actually kind of says the same thing.
Okay, this looks.
I can show you a picture.
Yeah. Go show me a picture. Yeah, that's this. I say what
Also,
would
like,
be.
What's it called? Okay, one other thing. I do have another one, but it's like kind of wants you to do the same thing, plot it out to see if I have connected the dots. But they kind of gave me a weird how do I say it? A weird name there. It's like this one was volume versus temperature, but this next one is kind of threw me off a little bit. It's something called activity.
Wow, this looks like
versus
really
time.
off. This is really off for a regression. What? ChatGPT messed up.
Oh, that ain't it. But yes, it's activity versus time for the next one, and it's like I'm trying to wonder what's the SI unit and the symbol for activity. Is it like capital A or anything?
Oh, Desmos has a built-in formula, does it? Oh, I didn't know that about Desmos. All right. Maybe he's right. One sec. Oh, there we go. All right. That's easy. Thank you, Oni-chan. Oh, you literally just hit this button.
Yeah, why do I hear Oni-chan every single time?
He's good. Yeah, good OG-chan. That's cool.
Okay,
OG.
yes, I'm going to send the picture. What do you want me to send it in?
You send it in the chat here if you want. That's fine. You send it in the Discord chat. What's up, Will Smith? Will Smith, did I help you out with like chem or something at some point? I forget. It's been a long time. Okay. Anyways, this is good. Good question, Ethan. I gave you 1 coin. Nice. Let me help out some of the students real quick. Let me see. I got Drizzy, anti-caffeine, and then QV. So first, I'm gonna ask if Drizzy's around. Drizzy, are you around in the chat?
I sent it in the wrong one. I sent it in the wrong office hours.
Okay, that's fine.
You see it?
I think Will Smith has a question. What's up, Will? Yeah, I see it. Okay, that looks fine. Yeah, I see it.
Okay. I'll show you the other one.
Okay. Let's see. What's up, Will? Will Smith,
Yo.
what up? What up, dog?
What's up?
What up?
So basically, I'm taking Calc BC this year.
Okay.
And I've kind of been like slacking a little in class.
Oh no.
And, yeah, we've had like something called sequences, and like all these tests, and I have no clue what they are.
Okay. Do you have an example homework question over them?
Yeah, sure.
Go grab one real quick, and then let me. How about Jamarcus? Yeah. Okay, Jamarcus. Yeah, you're right. Sorry, I forgot. Let me do yours. Okay, Jamarcus. Let's see. Jamarcus was asking. We didn't skip yours, dude. Okay. All good. Okay. I don't get the difference between force, work, and power, and what each one actually means. Okay, very cool. So force is equal to mass times acceleration, and this is like how much something is like getting pushed or pulled. That's kind of what I think about as like force. Okay. Work is equal to the force times the distance. This is the simple definition. The actual definition of this is the integral of f dot dx. basically just means you have to add up all of the force that is in the same direction as the distance something is moving. That's where this comes through. Ooh, Calc 2 series test. Woo! Oh yes. Oh, Obi. Yeah, I'm 100% gonna start. Yeah, I'm gonna tell Will Smith about all the calc courses we got. So yeah. So work is, it's kind of the amount of, we say, like, useful force that's being done. So if you're pushing something forward and you're applying all the force forward, you're gonna do a lot of good work. If, for instance, let's say you have a box and you're applying force diagonally like this, but the thing is moving this way, okay? Only the amount of force that is in the same direction as the distance. So we would call this like F parallel. Only this times the distance gets counted as work. This force is junk and is kind of like wasted. It really gets put towards like friction and stuff. Yeah. Different guy, Isaac Newton versus James Joule versus James Watt. Wait, are those two, were they both named James Dog? Are you serious? I didn't know that. So yes, so work is the amount of like useful force to move things. And then we have power, which is equal to the amount of work done over the amount of time. It's the rate at which work is done. It's dWdt. So this is like, if I were to make a graph of, no, not dW, sorry. Yeah, dW, yeah. So it's the work over the time. It's like this. It's the slope. The physics course I'm doing just sucks at explaining stuff. Yeah, I imagine it does.
Disqualified.
Anyways, yeah, units. This is newtons. This is joules, which is the same thing as Newton meters. And then the units for this are watts, which is the same thing as newtons meters per second. That's where these all come. They are all related, which is very cool. Usually you got to figure out the force on something. You figure out how much it moves and how much of the force was applied causing it to move. And then if you know how much time it took for that to happen, you can then figure out the power. That's where they all come from. Does that make a little bit more sense, Marcus? Also, yeah, I'll check out your essay. What did you do? Oh, you sent it. Oh, it's in like text form. Dude, these prompts, dude. A challenge I have faced, personal or academic, and what I learned or grew from it. It is a true story. Yeah, I wonder how many kids just write fake stories about this stuff. But, anyways, does that make sense? Oh, why does a light bulb use watts? Right, because it's the amount of. Okay, so this is also power. Is also. So work is an energy unit, okay? And so power is the energy that is used per unit time. Okay? So light bulbs are watts because they are consuming energy at a certain rate. So a very high watt light bulb consumes a lot of energy, joules, in a short amount of time. Exactly. Yeah, no. So force, work, and power in the kinematic sense, kinematics is like moving stuff. That's what this means. In terms of electricity, these are completely different things. Because then power in circuits is equal to the current times the voltage. And this is a totally different thing. Fun fact, James Joule was a student of James Dalton. Oh, wow. Electrons are being displaced. Poor electrons. Yeah, electrons are technically being displaced. Yeah, Talus is right about that. Why are they same but different? Physicists gotta lock the fuck in. Kind of what Talus said, because it's all energy. Energy is a lot of things. And dude, bro, when you start getting into relativity and stuff, then mass becomes energy. So, and there's that big concept in physics that energy. Mass can neither be created nor destroyed. It can only be converted between forms. So you can also convert into energy.
Oh, it is energy. That's a conservation of energy.
Yes, good. Yeah, that's the E equals MC squared.
That's the goal. I need to ask something.
What's up?
Like, okay, explain to me this. How can energy neither be created nor destroyed, but it exists? Like, it had to have been created.
Yeah, this is a deep question. Some people think it's God. Other people think there's something, for instance, a point of singularity, which is, I guess, the Big Bang, right?
And the Big Bang Theory. I knew it had something related to that.
Yeah, it's like there's a moment where everything just went poof, and then all of that energy started cooling down, and as it cooled down, it coalesces into mass. That's the general strategy. Where that came from,
And so-
you got to take that up with somebody, some higher power of sorts, because I don't know what that is.
Okay, but it's like c is equal to the speed of light, right? And E equals to mc squared.
Mm-hmm.
But if we already know the speed of light, why don't they just write the number down? It doesn't make sense. It's like
Because
put the number for
because it would be a big
squared.
pain in the ass to keep writing 2.997 times 10 to the 8th. Just don't. Yeah.
But-
In
Still, though,
physics,
it-
in physics, we use constants all the time. So, for instance, like k, right? That's 9 times 10 to the. It's technically 8.99 times 10 to the 9th. They're just things we don't want to just keep writing, so we just write k. It's the same thing with c.
Still,
C is
I think it will make
2.997
people-
times 10 to the 8th, but I'd rather just write c.
I think it'll make people's lives a little easier since you already have the number.
Well, if you're in physics, it makes life easier because you already know what c is.
Mm-hmm.
Which is why variables are good. Yes, they also change your mediums. Okay, cool. That's a good question. I appreciate that one. Jamarcus, really nice. Nice. Let's get all off the copy. Nice. Constants make life much easier. Agreed. Especially when physicists start saying that, like, what is it? Pi is equal to 3. That's engineers. Engineers start saying pi is equal to 3. Which is, kind of troublesome. But all right.
They should get, like the first 10 decimal digits of pi, which is like 3.14159265359. Do that. That'll make it more precise.
Yeah. And the 1912 Indiana State Legislature. Oh my gosh. All right. Will, what's up? Which question do you need help with for this stuff? And then QV, let me know if you still need help. You said Will had a question. I assume QV and Will are in like the same class or something.
Yo.
What up, dude? Pi equals E equals
Okay.
3. Yeah, that's the joke. Yeah. And yeah, C is equal to 1. What's up? Okay. Oh, convergence or divergence of series. Ooh.
Yeah.
Yeah. Okay.
So I was thinking just like maybe like 2 like from the first
Of
set,
each
and then-
one? Yeah, you're good. You're good. Write the decimal as a geometric series and write its sum as the ratio of 2 integers. Oh. Ha 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 ha. I forgot how to do this. This is 0.44. Okay, actually I do know how to do this. Okay. That's
Oh,
actually
okay.
Okay. So, do you see how the 4 keeps repeating? So, 0.4444 is the same thing as 0.4 plus 0.04 plus 0.004.
Yeah.
Do you understand that, right? Because I just keep adding like another 4 to like one of the decimal places.
Uh-huh.
Okay. So, this is like 0.4. I'm going to say times 1/10 to the 0. And then this is 0.4 times 1/10 to the 1. And this is plus 0.4 times 1/10 to the second. You see that?
Yeah.
Right. Okay. So
replace the exponent with n or
yeah, I think it. I gotta remember. I forget if it starts at 0 or 1. Geometric series formula. Yeah, exactly, Moochie. Yeah, right? I fucking forget all these. I think it's this one. Yeah, here we go. Simplex says it doesn't matter, dude. Yeah, it has to do with this. Okay. So it's AR to the n minus 1. Okay. That makes sense then. Because then they start at n equals 1 is what they do. Because if it's n minus 1, 1 minus 1 is 0, then to the exponent, this thing just goes to 1, right? He's like, yeah, watch.
Wait. So why do you need the -1?
Okay. because they don't start their series at n equals 0. They start their series at n equals 1. Right? And in order for this to start at n equals 1, I need it to be a r to the n minus 1, because then when 1 gets plugged in for the first one, this becomes r to the 0, which is what I need.
Okay.
Yeah? Okay. So
how would that work with like a trickier fraction, like the 0.215?
Sure. Well, that's point. I think only the 1/5 is repeating, not the 2 as well.
Yeah.
I believe,
Would
right?
that get 10 or-
So okay, that's 0.2 plus okay, plus let me see this. So this is 0.2 and then it's 1/5 1/5 1/5, right? Because the 1/5 just keeps repeating. So that's 0.15, and then oh man, what is this? That's to the -3, right? No. Times 0.015. It's actually kind of tricky, because then I got to know how much that this one goes over. So okay, one second. So I have point. Let me just write it out this way, and then I'll see it. So this is 0.2 plus 0.015 plus 0.00015, right?
Yeah.
Okay, now I see. So it's 0.1015, and then it's moving 2 decimal places over, so that's 1/100th.
Okay.
Right? So this is 0.2 plus 0.015 1/100th to the n minus 1.
Okay.
Right.
Wait. So another thing, would are we always gonna have like 1/10 or 1/100, or could it be like some random number like 1/27?
No. It'll always be a factor of 10, because that tells you how to keep adding them. So for instance, here, this one's like a little tricky. So do you see how I would write out the first couple ones just to see what happens, and then you can kind of see it, right? So here I have 0.075, right?
Yeah.
Plus 0.00075 plus 0.0000075, right?
Well, that'll also be 1/100, right?
So let's see. You're adding 2 zeros here, and then you're adding another 2 zeros here. So that's 1/100.
Okay.
Yeah.
Um.
Okay. Cool.
When we start at 0.075, would that be A or whatever it's called?
Yeah, that would be A.
Oh,
right?
okay.
Because then this is A times 1/100. And then this is A over 1/10,000, I guess. Yeah.
Okay, that makes sense.
The fun part is the total ends up being over 99. Does it? Maybe. Wait, what?
99.
Oh, a number of 9s equal. Okay, yeah. Oh, I see. Okay. Oh, never mind. They're talking about something else. Okay, dark matter. They're talking about dark matter stuff. Okay. All right. So that works for the first couple ones, right? And then you're talking about like convergence, divergence of a series?
Yeah.
Okay. What are you allowed to use? Are you allowed to use convergence testing or what?
Yeah. We learn a lot of different tests. I'm not really sure how they work.
Okay. This is actually something
that what's up? Put baby voice on. Zach. Do you know Zach? Do you know E to the 2I pi? Maybe you don't.
E to the 2. Isn't that like 0 or something?
it's equal to -1, I think. No, it's equal to 1. Wait, E to the 2I pi. I think it's equal to 1. Right? But yeah, no. We have another
math streamer who literally wrote, I think, a master's thesis on how to teach sequences and series. That was his like fucking like dissertation. And he's actually hosting a course about sequences and series starting tomorrow.
Really?
Yeah. So here I'm gonna send you the link to it real quick. Just if you want like some little extra help to it, and you're just messing around on whatever on Twitch. Yeah, tomorrow he's doing an infinite series review, and he's doing it. I want to say. I forget if he's doing it every week. Oh, he is. He's doing it every week, Tuesdays and Thursdays. So you could also ask him questions about stuff.
Yeah.
But anyways, here's the schedule for it, because it also puts down what his Twitch is, which is. Oh, he didn't put his Twitch on here. Okay, whatever. What is it? Wait 1 sec. E to the 2I pi. Does that work? Oh no, I think it's like exp 2I pi. There we go. This is it. This is Zach. Yeah. Here, I'll put this in the chat for you. This is his Twitch. He's great. Yeah, shout out to Zach, another great streamer. All right, but anyways, let's do your question. So there are a bunch of different tests you can use, and there's always a nice spreadsheet for this. Convergence tests, cheat sheet. Yeah, it's like one of these things. Ooh, this is it. Yeah, I think I like this one. Or I like this one. Yeah. Okay, let's use this one. I like this one. Because based on what the series looks like, you can use a different test to solve it. You can actually use multiple tests to solve things, but certain ones are easier than others. So, let's just pick one. Yeah, just pick one you want help with. Maybe like 63 should be easy, right? Okay. So we have this, okay? 4 over 2 to the n. And we want to figure out whether this converges or diverges. The first thing you want to kind of do is see which one of these things it kind of looks like, all right? So off the bat, this doesn't look like just a to the n. It doesn't. It a sub n. It looks like the term is something with like a power to the n. So I think this one, for instance, looks like a geometric series, where if we were to rewrite this, let's say sum is n equals 0 to infinity. This is the same thing as, we can pull the 4 out because that's just a multiplier. Anytime you have something just multiplying inside the series, you can pull it out of the series. This is 4 times, and then this is 1 over 2, all to the n. Because 1 to the n is the same thing as 1, and then we just wanted to write 1 over 2 to the n. So it's just like this. This looks very much like this. And actually, we could leave the 4 in there if we really wanted to. And we know that this is a geometric series which will converge as long as r, the ratio thing here, which is being raised to a power, is always the magnitude of it is less than 1. And so in this case, you'd be like, cool, this one converges by geometric series. Since r equals 1/2 is less than 1. Or we'd say technically have to say the magnitude of r, which is absolute value 1/2 is less than 1. So yeah, that's an easy one. That's a very easy one to pick out. And I don't think, when they say determine the convergence or divergence, sometimes they want to know for what values of x it converges or diverges. Here, I don't see any, I just see n, which n refers to what the term is in the series. So we're not trying to find radii of convergence. You're not trying to find, there's not some additional variable x, and they're saying, okay, what values of x can it be in order for it to converge, and what does it need for it to diverge? That's the next step. That's the next thing they're going to ask you. Let me see. Ooh. I like these. These are sometimes pretty cool. Oh, first of all, yeah. Will, you still here? Did Will die? Uh-oh. What happened to Will? I can't hear you, Will. You're muted. Try unmuting yourself, maybe.
I didn't realize I was muted.
Yeah, you're good. You're good. Okay. Okay. Does that make sense so far?
Yeah.
Okay. Right. This one looks like a geometric series. Cool. When I see stuff like this one, for instance, this to me looks like a telescoping series. Have you heard of the word telescoping series?
Yeah. I think I've heard my teacher say it before.
Yeah. What it means is like the next term cancels out like 2 terms before it or something. It telescopes.
Oh, right. And so like usually the first term is what it like converges to, right?
Yeah, exactly. So it's something like this. It's like this cancels out this and this cancels out this, and then there's just like something left. So what can be helpful to do is to write out the first couple terms here. They say it starts at 1. So that's 1 minus 1 over 3. Cool. Plus. And then now n equals 2. So that's 1/2 minus 1 over 4. And you're like, cool. Okay. Plus n equals 3. 1 over 3 minus 1 over 5. And what you start noticing is, look, the minus 1/3 will cancel out with the plus 1/3 here. Goodbye. Right?
Yeah.
And then the 1/4 would cancel out with this one, and so on and so forth. So the only term that is left is going to be the 1 and the 1/2. So it converges to 3/2. But yeah, you can say this one by like telescoping.
And the telescoping, is that just like writing out the terms, or what is that?
You need to write them out. You need to write them out and notice a pattern. There's not a specific test for it here.
Right.
You probably could combine these as fractions and then use the ratio test or something to do it if you wanted to. But the easiest way is to just write out, anytime you see 2 fractions, dog, and they're like subtracting each other, write out the first couple terms. And you should see that it telescopes. Wow, this is a tricky one, this one right here. Jesus. This one diverges, right? This is just a geometric series, but r is not greater than 1. That's easy. This is going to diverge too, because you can also just check to see, like, does the last term go to 0? In this case, this is like 2 to the n, I believe, right? 2 to the n over 100. The last term just keeps getting fucking big, so that always diverges.
So it's kind of like limits in a way, right?
It is. No, it's very much like limits. It's one of the easiest tests to do. You should always check this test first. Always check to see, as n goes to infinity, does that last term go to 0? If it does not, it's easy. You're just like, cool, it diverges. So,
okay.
For instance, this one, as n goes to infinity, if you took, what would happen if you took the limit of this? Like, fuck this. Just look at this. What does this become as n goes to infinity?
Well, wouldn't you have like infinity over infinity?
You would, but you should know this. This is an asymptotic behavior. Do you see how? Did you ever do this, like horizontal asymptotes for polynomials?
Yeah. Okay.
Do you see how the degree is 1 on the top? It's also 1 on the bottom.
Yeah.
What does that mean that like asymptotically goes to?
What, infinity, right?
Well, no. Remember, so this is why we have to remember everything, unfortunately, from previous math classes. If the power on the top is the same as the power on the bottom, you look at the coefficients in front of those terms, and that becomes. So this is 1/10. It's 1 over 10.
Okay.
Yeah. The other way to do this is always.
You're right. It's like the highest order, like.
Yes.
Yeah.
Right. So since the last term approaches 1/10, and that's not 0, this diverges. Just off the bat. That means this also diverges. Just done. You can do these really easily. This, for instance, does
0, right?
does go to 0. So you have to do more work. Okay. What I would do on this one is I would write this out. I would expand it out. So I have 1 over n squared plus 3n. Right? Okay.
Okay.
And now what you do is called the you can do the limit comparison test, or you can do the direct comparison test. 2 ways to do this. Basically, comparison test means does this thing look like another series that I know diverges or converges?
Okay.
So this, if I were to make this simpler, would look like 1 over n squared, right?
Right.
Does this converge or diverge?
Doesn't that converge?
It converges, right, by the p series test. You see how it says this is the 1 over n to the p, right? As long as that power is greater than 1, it's going to converge. If this was 1 over n, then no, right? This would diverge. Now, the important thing I'm saying here is I know that this converges, okay? So if we were to look at, for instance, in terms of like terms, right? We know that this converges. The purple one does. What do I need to show that the red terms do in order to show that it will also converge?
Wait, sorry, that the red terms converge?
Yeah. What do I need to show?
We have to show that 1 over n squared plus 3n is equal to n squared, 1 over n squared.
That it's less than. It's less than or equal to. This is obviously not equal to this. Yeah, that it's less than. If you show that this thing is always less than this thing, and I know this converges, then this will also converge. And yes, you can show that, okay, cool, look, n squared plus 3n will always be greater than or equal to n squared.
Okay.
Because it's the same shit, right? And n is always positive, so you're just adding more and more numbers. And since you're dividing by a bigger number, that means this will always be smaller than this.
Right.
Right?
Okay, that makes sense.
So
And
that's a
if
direct
it's
comparison
like-
test.
Let's say it's like 1 over n, right? Would that mean that we want to like prove that it's bigger? So
Yeah,
that way
exactly. Yeah, so
Okay.
if for instance you were comparing to 1 over n, now this doesn't work, right? Because this is always smaller than this. So now I'd have to, in this case, this would now diverge. Okay, so I have to show that something's bigger than it. The only way to really do that, right, would be to say, okay, maybe I have like 1 over n over 5 or something, which is the same thing as 5 over n, right? Well, 5 over n is always bigger than 1 over n. So it's also going to diverge. Yeah.
And what if like you don't get something smaller or greater, like?
Then that test doesn't work, and you got to go figure out something else. This is the annoying thing about sequences and series, is there's never any this will always work. You have to try things. If they don't work, you got to go try something else. It's actually kind of like a metaphor for life. Like shit just doesn't work all the time.
Yeah.
You got to figure it out.
You get like a sheet, like a cheat sheet and a PC. You do?
On the test, no. You don't get a cheat sheet on the AP exam, no.
That sucks.
Oh, yeah. Obi says it's almost like doing actual math. Yeah. It's why it's one of the cooler things. My favorite, I'm actually curious, Obi, what's your favorite test? My favorite test is the ratio test. This thing is like the beast. It takes out a lot of things. You can usually brute force things with the ratio test if you really want to.
Oh, really?
Yeah.
Okay.
It's especially useful for polynomials and factorials. Okay, if you ever see factorials, you need to use the ratio test. The ratio test will save your ass so many times. Anytime you see factorials.
Okay.
You don't have any of that here yet. Yeah, I don't see anything. This, for instance, would also diverge, because as n goes to infinity, you have the ln of 1 over infinity, which is like the ln of 0. The ln of 0 is like negative infinity. It's hugely negative. So this also diverges. So you have to remember some properties of things. Also, like arctangent, as n goes to infinity, I believe that goes to pi over 2. Like arctangent looks something like this. So as n gets bigger and bigger, the value of arctangent just goes to pi over 2. I believe.
Wait, but also diverge, right?
It diverges, yeah, because the last term never goes to 0. The last term just goes to pi over 2. Yeah, cool. Such wisdom.
My man.
Yes. Okay. Yeah, it looks like, at least for what you're doing in this homework, man, you're probably only using the nth term test, the geometric series test, and P series and direct comparison. That's what I would say. When you get to later homeworks, yeah, please combine. I can help you out with like how to use the ratio test. The integral test is pretty cool too. And alternating series.
I just have one last question.
What's up, Doug?
It's a homework question, but I was just wondering, like, if you knew of any any internships for like high schoolers.
Ooh, where do you live?
Washington.
Washington State?
Yeah, but I can move to I can easily get to California because my dad works there.
When do you want to do your internship? Over the summer?
Yeah, over the summer.
Okay. Off the top of my head, no. California's a little weird. I would actually recommend not doing an internship in California because I think by law the internships have to be paid. And so a lot of companies don't want to shell out cash for a high school student who, no offense, but you don't fucking know anything.
Right.
It's okay. That's the point of an internship, is to learn. But they tend to reserve those for college students who they know they're going to hire out of college. If you were in college right now, I could line you up with a gazillion internships because I know tons of companies that are hungry to like hire you out of college, and they're totally fine with training and paying you whatever. I'm trying to think what I did in high school personally is I found, I grew up in Texas, so they didn't have to pay interns. I found a robotics lab next door and just asked if they needed someone just extra help, and I said I'd work for free, and they're like, oh cool, yeah, you can work for free for the first month, and we'll pay you minimum wage like afterwards. And I was like, cool. And it was just great for my resume, right? You're doing this for experience and resume, probably.
Right.
Exactly. So yeah, the best thing would be to ask around to see what labs. I mean, there are. I can probably just do. We'll see, like high school.
Yeah, I got accepted to this one project called So Krypton. It's with this MIT professor.
Oh, sick.
Honestly, I don't understand any of it. If I'm gonna be honest.
Okay. It's okay. Don't worry if you don't understand anything. That's the whole point. That's why it's an internship. Okay. It's an internship because you're supposed to be learning, and there's not very much expected of you. And honestly, some internships you're literally just gonna be like sweeping the floors for like the first weeks.
Yeah. Okay.
Because they got to train you. They got to teach you things. You're not expected to know things.
Yeah. Okay.
Maybe know some math. But if you
also
already
know object-oriented programming.
Cool. Yeah, object-oriented programming. That's what they're doing.
Yeah.
Yeah, that's a great thing. I mean, if you want to prepare for that internship, do you know how to code?
I know Java and a little bit of Python.
Perfect. Then you're fine. Because you'll learn everything else on the job. Yeah. One second. The chat's saying some stuff about you. I need an internship for IT. Yes. So IT internships, again, just look up, I'm sure Google, whatever, Amazon. I mean, in Washington, bro, you're right next to Microsoft, right?
Yeah.
Here we go. Here's a 4-week internship at Microsoft, right?
Oh.
Applications open in February 2025. Perfect, right? Yeah. Oh, wait, this is a bachelor's program. Well, whatever. Yeah, it is a little tough. Also because you're minors. You're not adults. That's the problem. If you are over 18, then you can make decisions for yourself. A lot of big companies just don't want their HR department to have to worry about, we have minors in the building that we have to now worry about things. Once you're an adult, they can deal with you however they want. So I think local companies are the best for high schoolers. Yeah. Someone said, I had an ex who found a company to hire as a secretary. Then she learned how to do legal documentation in her spare time. Yeah, perfect. Yeah, so don't worry about what the position is. Don't worry if you don't know anything. Just getting your foot in the door and getting your face recognized by someone at the company will be immensely helpful. And also, when you need letters of rec, having an MIT professor to be like, hey, this guy's cool, will help you out so much in whatever you need to apply for.
Okay.
So just do it. If you're already accepted and you got it, run with it.
Yeah.
You'll learn stuff on the fly.
Okay. Thanks, Dr. Gold.
You're welcome, dude. Come by anytime, dude. Nice. Let me see. 69, Kaz Tanek, 69. Nice.
Nice.
How does internship works in the U.S.? Out here, you just get a form for your employer to fill out. If so happens that they said the employer, your close relative, you know. John, stay away from the new intern, please. Why is it creepy, John? Why is it always? That's too funny. I got a professor from Italy. Nice. Yeah. Professors are great. And I know, for instance, at UCLA, they have something called the lap tag program. I wonder if it's still around. But if you wanted to get into plasma physics, there's a program that teaches high school students about experimental plasma. So you could apply for this, for instance. I guess the link is not working, but okay. But yeah, check out your local universities. A lot of them have outreach programs in these fields, especially the sciences. And that's probably your best way to get in. By definition, unless you're in the state of California, internships are almost always unpaid because they don't, because I mean, no one has money these days. Oh, that's cool. Is 4K tuition good for computer science? Oh, thank you, Raven. Yes, I did survive.
My man.
Yeah. I would maybe be careful about going into a computer science degree these days. It's kind of unknown. With AI is kind of shaking everything up. You're gonna learn a lot of good stuff, but I don't know if I can directly recommend just learning how to code at this point, because AI is really just gonna, I mean, even if anyone watched the Joe Rogan podcast with Mark Zuckerberg, it was last week, he said we're a year or two from just replacing all of our mid-level coding with AI. And I get it, because it is kind of it's a language, and it's a large language model. It can learn it. More of project managers and maybe like big software, like high-level software managers, software developers, those probably won't be replaced by AI. But going in just to be a coder, that's kind of a dead-end job at this point. I wouldn't do it.
Is that the goal?
Yeah. I haven't read.
Can you say something?
What's up, dude? What's up? What do you want to say? Oh,
for me in my physics class, we're actually looking at the periodic table right now.
Okay, that's cool. Periodic table. Well, in physics, that's interesting. Let me. How about Ace? Ace needs help because he's been waiting forever. But keep going. What's up?
Yeah. I've been looking at the periodic table, and I found some jokes online as well. Like, take this for example.
What's the joke?
Like, here this. I want gold without the A. You get it?
I want gold without the A. Oh, I want you. Ace is still here. Thank you.
Yeah. AU is gold, but if you put the A, then it's I want you. Or like something that had involved like oxygen combined with magnesium to make OMG.
Oh, that's too funny. Yeah, I know what you're talking about. The periodic table jokes. Those ones are good.
Mm-hmm. Those ones actually kind of get me. Hence why I love science.
Yeah, science is great, dude. We love it.
Nice.
Here, let me have about Ace because he's been waiting for a while, and he's got a test coming up. Oh, and Swaz, you got questions? Good. All right, we'll do those afterwards. All right, let's see. During the oceanic flight A15 from Sydney to Wait, Sydney is in Australia. Excuse me. How do you go from Sydney? That's like saying I'm going from Los Angeles to the United States. But okay. Experiences an emergency and breaks apart mid-flight. But the plane's passenger is miraculous. Is this an episode of Lost? And crash land on a mysterious island. Oh, it is Lost. Okay. One of the survivors wakes up in the middle of the jungle after. Okay. Assuming the plane was falling above. Okay. One sec. Yeah. How did they survive? Right. Oh, all robots became aware and then just left. Human decided that creating any smart system was unethical because they might become aware.
Isn't that the premise of Dune, Obi? Have you read Dune? Dune is kind of like that. Thanks for the baby voice, too. Okay, assuming the plane was falling at a height of 300 meters. So 300 meters up. And then this is annoying. Wait, is it falling 450 kilometers per hour down?
Okay. Dude, whoa, what's going on? There's so much stuff. Dune rebelled, Psalm for the Wild built, and they just left. Oh, interesting. Oh, yeah. Famish turned on my high-pitched voice. Okay. So, this is so wacky, dude. What's up, Nerwino? How's it going, dude? Yeah, shout out. Nerwino is an awesome person. I like you. Nerwino, you're cool, dude. Shout out Nerdwino, another one of our awesome science math streamers. I think Nerdwino, I think you do like astrophysics stuff. You can take advanced math colleges for community college. Yes, yeah. You should always try to take as much as you can at community college first. It helps you get into regular college pretty easily, because if they say if you can show to a like UCLA or whatnot that you're able to take college level courses and pass, they're more likely to accept you. And plus, it's a lot cheaper. Astronomy and astrophysics, yeah, for sure, dude. I think someone in our chat, I think Jamarcus and whatnot, they were all talking about the Big Bang and stuff. They were earlier in the chat. They were, yeah. Go follow Nerduino if you want to go ask about how the universe started. Yeah, there's some cool stuff there. Yeah, I think coding skills are always a great thing to just know. You should always know them. Not necessarily going into work to be a coder, but just knowing how things need to be written, like logic-wise, in order to do coding is super useful. Yeah, Nerduino says he has all the answers. Yeah, so if you want to go ask about the beginning of the universe, please, yeah, go follow Nerduino. Go ask him on history. I think it's just some like spiritual force called the singularity that exploded, and then. Yeah. Oh, archive links. Nice. Okay. Let's see. He's 65 kilograms. After flung an airplane at a height of 300, as with the plane, calculate the force of impact and the coefficient of friction in the air as Jag hits the ground. Assuming he loses 10% to the surroundings as he falls, he comes to a complete stop. Oh man, your teacher's writing so much wacky shit on this, dude. What?
Surprise, motherfucker.
God damn. What's going on? Okay. I'm going to convert this into meters per second, just straight up. Yeah, and create. Okay, so this is 125 meters per second. Okay, nice. Because kilometers per hour is garbage. Like, that doesn't really help us out. And I assume he's moving in this direction, so he's falling like this. Okay. All right. He loses 10% to the surroundings. Okay, so he's going to lose 10% of his energy as he falls in this direction. The issue is that energy lost to... So the coefficient of friction in the air and the energy lost from that. So energy lost to friction is always equal to the force of friction times the dot the distance. And the force of friction for air drag is actually quite tricky. Because it's proportional to the velocity, I think. Yeah, this is it. Bro, is your teacher really asking you to do this? Yeah, it has to do with this. It's 1/2 rho v squared c drag, and a is the cross-sectional area, which I don't think they gave us any of that. Well, they gave us the mass of him. Okay. Yeah, this is a ridiculous question. Because you have to integrate this over the distance. I think I can integrate it dv. And also, there's not really a coefficient of friction. Ace, is this really a question on your test, dog? Because there's a lot of things wrong with this. First of all, yeah, what equation does... There is no coefficient of friction in the air. That's not a thing. There's a drag constant. Oh, man. And then they're saying, assuming he creates an impact crater. Yeah, please, yeah, give me the solutions so I can see what he's doing. There's too much missing information in this question. I don't know how big the person is. I don't know the cross-sectional area. I don't know what they're calling their drag constant. Yeah. It is air resistance, but air resistance is tricky. So they're trying to treat resistance as something nice and easy, which is right. If you have a box and you're applying a force, then yes, you have a force of friction. And this is equal to mu k Fn, where this is Fn, and then this is mg. Okay? This is easy. This is the force of friction for something moving on a rough surface. The force of friction in the air doesn't really have a coefficient of friction. Like, it doesn't have a mu k or a mu s. It has a bunch of terms, which is this. You can approximate some of these. I know there's... maybe they're asking for the drag coefficient. But then we need to know, like, things for, like, the density of the air. And then we need to know the cross-sectional area, which I think there is some number for, like, a body, because I've seen this. You can calculate the kinetic energy. Yeah, for sure. So, for instance, we could say the kinetic energy before. Right? Which is 1/2, and then his mass is 65. And then the velocity he's moving at is 125. Squared? Sure. I can do that. It's a good first step. So 0.5 times 65 times 125 squared. So that's, let's call that 508 kilojoules. Or we can say 508 times 10 to the 3. Joules? Okay. And then we're saying that 10% of that is lost to the surroundings. Okay. So that means 508 times 10 to the 2 joules is lost to friction. All right, cool. We got solutions from this guy. Let's see. Whoa. Oh my god, what? No, this is so wrong. He says it's mu mg times delta d? Bro, no. No. That is not how air resistance works. Air resistance, first of all, is not a constant force. It depends on the velocity. It goes as the velocity squared. Yeah, you're totally cool, Nerduino. Yeah, don't worry about... No, you can talk about whatever in the chat. You're fine. What's air? But yeah, please. Yeah. These are... Yeah, Nerduino, when do you stream, by the way? So, maybe... Do you have a calendar we can look at? I'm pretty sure I follow you on Twitch. Oh, 1 second. There we go. Pretty sure. Yes, I do follow you.
It's delicious.
Oh, you know Ballant and all them. Oh, that's right. Yeah. So yeah, this is Nerduino. Go make sure to follow him. Sunday and Tuesday at 8 p.m. and Thursday at 6 p.m. all Pacific. Awesome. That's cool. If I'm still streaming on Tuesday at 8, let me think. I start streaming at 4. Well, that's 4 hours of streaming. I probably won't be on till 8. But yeah, make sure, go follow him. He's a great guy. Yeah. Yeah, so your teacher, Ace. I mean, this is a really dirty approximation to it. But they're saying that the work done by the air is the force of gravity. Okay, so they're calling dude, this is so dirty. Oh my god. What? Oh my god. Okay. All right. Let me. So usually, remember how I said that like force of friction is mu k times Fn? So it's usually mu k, and then Fn is usually equal to mg. So this would be the force of friction. And then you would multiply that by the distance to then get the energy from friction. It is a very bad question. This is a very bad question. So here, let me just like go through the solution and just explain the parts, because I'm not actually going to do this because it's wrong. But we can. Oh, that's his Twitch. One sec. Let me pull this up. It's okay. The teacher was getting a little overzealous, but okay. So Raven Violet was correct with, let's just calculate kinetic energy. And let's see. I think he said it lost 10% of the energy. So yeah, so it's actually the kinetic energy plus the potential energy. Oh yeah, you're good. Yeah, Jamarcus, come to more streams.
Good job.
Yeah. Yeah, this is really fun. Nice, dude. I appreciate it. Yeah, more butterfly effect, dog. So this is the total energy, and then this they're calling the work done by friction, because again, this is mu, and then Fn is mg, and then d is the distance it drops, which is the 300 meters. Okay, so this gets you this. This is very wrong. It's a very wrong way to do this question, but he wants you to know how to do it. Cool. The force of the impact. Okay, so that has to do with energy. Right, okay. Work done on the ground by Jack. Loss of energy due to... Where's his EB coming from? Oh, okay. He's saying situation A is when he's in the plane. B is when he hits the ground. Okay. So his energy at the top when he's in the plane has to equal his energy when he's hit the ground. And when he hits the ground, his energy is going to be the work done on the ground by Jack plus the work done from the air resistance. So 90% of this total energy is now the work done on the ground, okay? So that's, he does write this, right? You see how it says 90% of it, yeah? And then, yeah. So the work done on the ground is the force done on the ground times the distance that force is done on the ground. So this is F times delta D. And delta D, we said, is he makes a 2 centimeter impact crater. So he moves into the ground for 0.02 meters. So that's why D here is 0.02. So it's just 90% of the total energy when he was at the top of the plane, right? Divided by 0.02. And then this gives you the amount of force that the ground applies to Jack. Because the amount of force that Jack applies to the ground is the same amount of force that the ground applies to Jack. And that's a huge number. It's something times 10 to the 7th. So that is much greater than 4,000 newtons. So Jack is dead. Yeah. What is that sentence at the end? We can assume Jack should not have survived. Poor Jack, dude. Sad for Jack. Let's cry for Jack, dude. Yeah. He didn't make it.
Oh no.
Anyways, does that make sense there, Ace? You have to kind of just oh, one second. You have to kind of just use his funny math for how he's doing things. Because I don't agree with saying that the energy lost due to air resistance is just mgd. it's proportional to the velocity. Is it still confusing to you? Do you want me to go over certain parts of it, Ace? I mean, you have to break it up into a bunch of different situations. The air resistance part, yeah, that's weird. So in physics, we call this hand waving. So hand waving is the way to tell people, don't worry about it. A lot of times students will say, hey, professor, that doesn't make any sense. How did you get that? Why did you do that? And professors don't really want to explain it, or there's kind of a bullshit explanation anyway, so they just wave their hand. They're just like hand wavy. Yeah. Yeah. Oh, Nerdwino, you have a hand wavy? You have an emoji for it? Dude, that's great. Yes, it's like he's hand waving for sure. This is 100% hand waving. When he starts saying that the work done by air is mu mgd, because it's not. It's supposed to be this, and then I would have to do this dv, and then I would have to integrate from v1 to v2. This is the correct way to do it. That's actually Astro Canuck. I love that there's a hand waving. That's awesome. Astronomy wave. I wonder if it's meant to be like hand waving. Well, let me go follow this person. That sounds super fun. Yeah. Here, let me give him a follow. That's cool. I love all the science people on Twitch. It's really fun. Astrophysics, we're kind of kindred spirits. I got my PhD in plasma physics, which plasma physics is sometimes in the astrophysics departments. Depends on the university. Right. Yeah, don't worry about this. This is the correct way to do it, but this requires calculus, and honestly, this wouldn't even be a college first year physics question. This would be a college second or third year physics question. Yeah. Anyways, yeah, cool. Your teacher's weird, but it's okay. Let me know if you got more questions about stuff. I'll go. Let me go through some other people's stuff too. Fuck this, Lamau. Yeah, I agree. Fuck this. Okay. QV, do you need help with yours, QV? We're doing hex to binary and hex to decimal. That's kind of cool. I know QV's in the chat. 100% correct. Yeah, that's the other thing, Oni-chan. Yeah, is there's also the problem of that in this question, the velocity vector is like this. The velocity vector is changing, right? Because he's following a trajectory. And if the plane was falling at 450 kilometers per hour, I assume its velocity is not all in the x direction, right? It should have a component in the y direction as well, right? If it's falling. So yeah, in reality, this is a very difficult question to do correctly. This teacher just did a lot of hand waving to get to the right thing. Right, it should include vectors. It's actually almost like a vector calculus question at this point. Don't want to do that. Nope. No. Anyways, okay. I don't see QV. Swaz, I can help you out. What's up? Which one, you need help with 28 and 30?
Yeah.
All right, let's do it. Can it be just projectile motion? Yeah, it should have just been a projectile motion question, but when they started doing energy loss to friction, now it becomes more than just projectile motion. It's quite. Oh yeah, let me get rid of your your email here, dog.
I mean, y'all can email me if y'all want.
Okay, well, just not gonna dox you totally, right? If I could do this. Okay, there we go. All right, yeah, there you go. Okay. Which one? 28?
Yeah, 28 and 30.
Okay. In a residential neighborhood, the median value of a home is $200,000. Dude, what neighborhood is this, bro? Not Los Angeles, I'll tell you that. Especially after these fires, dude.
No.
Every house is about to get, like, ridiculously expensive to try and buy now. For which of the following sample sizes is the sample mean most likely to occur, above 250,000? Oh, interesting. You had North Carolina in 1990, which is where I was born, actually. And also, I was also born in 1990. What do you think the answer is?
What do I think it is?
Yeah, I'm just curious. What do you think it is? Do you think the sample mean is more likely to be 250,000 if I take a lot of samples or if I take very few samples? And then try to, like, think why.
I think it's impossible to determine without any information.
It's not totally impossible. Okay, so what we have to remember is what's called sample standard deviation. Okay. So okay, we say the median value is 200,000. Let's pretend that's the mean value. Okay, median means it's all the same shit. Honestly, whatever. I mean, the answer may be E, but I can tell you what I think it is. Statistics is always kind of, like, subjective.
D? You're saying D?
I think it's A, actually. I'll explain why. Okay.
Oh, because, like, a low amount of results.
So if you have a distribution like this, right? Let's say this is the population, okay?
Yeah.
And the population has I'm going to just say a mean, whatever. We also have to assume things are normally distributed at this point. But okay, if this is 200,000 and I pull out a small sample out of it, okay? That sample I pull out will have its own standard deviation. So let's say this has a standard deviation of, let's say it's a crazy standard deviation. Let's say the standard deviation is 100K. Okay? Could happen. So that means you have houses as low as like 100 and as high as 300, okay? Out of all the houses, all right? If I take the average of just picking one house, right? There's a decent chance that one house I pick could be over here, right?
Yeah.
But if I pick, let's say, 2 houses, and I now take the average, well, I need them both to be up here. Because if I get one here and one here, what's the average going to be?
Like...
It's going to be more in the middle. Yeah, right? Yeah. So what happens is, as your sample gets bigger, and you start picking more and more things out of the population, your sample mean becomes more likely to be the same as your population mean.
Yeah.
Because you basically start becoming the population. Does that make sense?
Yeah.
Like, the population is everything. So,
Seriously?
and where this comes from is that sample standard deviation, S sub x, is equal to sigma over the square root of n. Okay? So this is the standard deviation in the sample. So, as your n goes up, your standard deviation in the sample goes down, which means your sample is more likely to have the same mean as the population. Yeah. So, for instance, if this is the population and then I pull a sample, the sample is also going to have some mean and standard deviation, okay? And the standard deviation of that sample gets smaller as your sample gets bigger. So eventually, I mean, like, your sample looks like this, and it's gonna mirror exactly what this is. Yes, but Raven's Violet is right, is that there's a lot of assumptions here. We're assuming that it's normal, it's Gaussian. We're assuming it's, you know, whatever, bell curve. Yeah, it's random, whatever. There's no outliers. So I think the answer is A, but it could also be E. It's definitely not the higher ones, because I want you to understand that, like, as your sample gets bigger, your sample's going to look more like your population.
Yeah. Yeah, it gets more, like, evened out.
Cool. All right, yeah, so I would say A. What was the other one? 30?
Okay. Yeah, 30.
The math department at a small school has 5 teachers. The ages of these teachers are 23, 34, 37, 42, and 58. Suppose you select at random 4 teachers and calculate the sample minimum age. Which of the following shows the sampling distribution of the sample? What the hell?
That's what I thought.
Dude, what's going on here? Wait. First of all, your sample should never be that close to the size of your population. I think samples are supposed to be less than 10% of your population. So in this case, I would need to sample half a teacher because 10% of 5 is 0.5. Suppose you select a random sample of 4 teachers and calculate the minimum age. Which of the following shows the sampling distribution of the minimum age? Bro, what? Dude, excuse me.
That's what I'm saying.
Dude, what is this textbook smoking, dog?
Maybe the minimum, maybe A.
Well, okay, a random sample of 4 teachers when there's only 5, right?
Yeah.
So you're either going to get like these, right? Or you're going to get these, or you'll get like this and this, right?
Yeah.
Half a teacher, the math is dark today. So in general, you're almost always sampling all the teachers, and the minimum age will almost always be 23, right? So for instance, if I take a random sample of 4 teachers and I get this, what's the minimum?
23.
Right? Okay. Let's say my random sample is these first 3 in this last one. What's the minimum?
23.
23. Do you see how it's almost always 23?
Yeah.
But there are going to be some times when, for instance,
I think I get it now. So maybe like
right?
B or C.
I think B or C. Well, B would be like all the time, which nothing happens all the time, right? So I think
Yeah.
C.
So probably C.
I think C. I think it's C. It's a shitty question, but I think it's C. And then, Shantrix makes a very good point. Thank you, Shantrix. Shantrix makes a very good point here. Since you have to pick 4, there's no way for the minimum age to be above 34. Because watch, if you picked these 4, right, the minimum is still 23. If you pick these 4, but like the second you don't pick this one, the minimum is 34. Otherwise, any other combination will have to include the 23. That's actually a really good observation, Shantrix. Yeah. Okay. Yeah, that's a weirdo, but yeah, it's C. Yeah, it can't be this one. And this, I think, I don't know why there's just 1 dot, but no. And this is saying it will always be that, which no, there's the chance that you get this, and then the minimum would be 34. Yeah. Cool. But
yeah.
Nice.
How many? I have 1, 2, 3, 4 left.
Okay. Just post the screenshots, or is it the same page?
No,
let me help.
Different.
All right, go find it. Let me help Ethan. Yeah, I'll do him. You're fine. Let me help Ethan out. Ethan, what's up, dog? Activity of radon. Let me see if Ethan's around. You need help as well. Yeah. What's up, Ethan? Do you need help with this question? Is that what you wanted?
Yeah, same thing.
Okay. So you want to like graph this?
There is one question. Yeah, graph this as well. But there is one question I have.
Okay, what's up?
It's like you see how every one of these like how do I say it? Quantities have a unit and a symbol.
Yes. Becquerels.
What's that?
BQ is becquerels, which refers to like radioactivity, and then S is seconds.
Yes, I know that. But it's like, what's the symbol for both of them? Like, I know time is T.
Oh.
And then there's minutes. But like, what's the one for activity?
I can just put A.
Wait, really?
Yep.
It's just.
Yeah, just say A. It's just activity. I think. Well, I'm converting this to a spreadsheet. One sec.
Oh yeah. Actually, if I were to look it up, it does say A for activity.
Let me see. Make it so. Okay, whatever. I think this will work. Yeah, Becquerels. Yeah, Becquerels is it's probably like Curies too, or Rontgens. Is that the other one? Rontgens. Let's pull it up. Nice. Okay, cool. All right. So usually I want to switch these columns. So I'm going to do this. Insert. Chart. And there you go. Do you see that?
That's the graph.
Yeah, that's a graph.
My one looks a little different. I don't know if it's the same. It does go downwards like that.
Yeah. This is a decreasing exponential, actually, is what it is, which you could fit this.
I see. I'm just kind of confused though. It's like, why does the teacher want us starting from the top this time instead of the bottom at the origin?
Oh, because the activity starts high and then goes down.
That's how it is.
Yeah.
Okay, I'm gonna show you.
Dude, what is EnigmaBot doing?
I'll show you the picture.
Okay, show it to me.
The teacher said to not draw a line or a curved line yet. For some reason.
Well, this is the graph, right? And then
why.
here, so it's not linear. It's definitely not gonna be a linear regression. So you can tell it, for instance, to be exponential, and then this looks pretty good.
An exponential.
It is exponential. Do you see how it kind of follows a curve that goes down? Oh wow, this is. Yeah. There you go. It looks kind of similar. Yeah. It's kind of a similar graph.
Yeah. So I don't know why he doesn't want us drawing a curved line yet.
Because you haven't learned how to do exponential regression. This requires the use of logarithms.
Logarithms?
Yeah, logarithms.
Oh no.
Oh,
I never learned those.
yeah. That's cool. You could plot the residuals. Wow. Dude, there's so many. Dude, Desmond's pretty fucking dope, dude. Wow.
That's dope.
Radon has a half-life of 3.8 days. Wow. Do you guys have radon screening apps? I don't think we do. Let me see. Becquerels.
And
Curies.
Dr.
What's Rontgens? Yeah, Rontgens is exposure. Oh, that's cool. It's coulombs per kilogram. So, for instance, it's this is what they use to measure the radioactivity that a human can take. So it depends on how heavy you are, right? If you're a bigger person, I guess you have more exposure. Yeah, right. That makes sense.
All right, well, Dr. Roll.
Yeah.
There is one interesting fact I know about a little bit about logarithms.
What's up?
It's like, how do I say it? I don't know what kind of math language you use this, but it's like, if you take the log of a number at the base and you have 1 inside the brackets, apparently it's always equal to 0.
Yes, it is. Do you know why that is?
Like, why? Explain the logic here.
Okay. So you have to remember what like the exponential form of logarithms is. So
What is it?
if I have log, let's say I have log base A of B is equal to something, right? Okay.
All right.
That means that A to the something is equal to B. Okay. Let's assume we're taking the log base whatever of 1. That means whatever my base is to some power has to equal 1. Okay. In that case, right?
Could you repeat that?
Okay. So I said log base A of B is equal to something. So that means A to the something equals 1.
All right.
This is called the exponential form of logarithms. That's how logarithms work.
All right.
Okay. So let's pretend a is just like, I don't know, 420. 420 to what power gets me 1?
It's 0.
0. Yes. So that's why the log base anything of 1 is always 0. Even like ln of 1 is equal to 0.
Ln of 1?
ln. Yeah, ln is log base e.
E?
Mm-hmm.
And E isn't E equal to like 2.7 blah blah blah?
Yeah, 2.7 blah blah blah. Yeah. Or sometimes we just say it's equal to 3.
Oh no.
I said 2.7. I call it 2.7.
I agree. It's 2.7. Euler's number. Yes. Yeah.
But still though, it's like, am I really gonna be dealing with logarithms in physics?
Yes. Logarithms are super useful in physics. Yeah. We use them in everything.
Alright, and yeah. Okay.
I use
well,
logarithms every day.
Every day, dude. Yeah.
Alright. But I can say
Logs.
that, and since the line is not passing through the origin, I could say it's like linearly related or something.
It's not linear. No, it's definitely not linear.
So
I
then
mean, it
like,
might be.
Well, it's not curved. It's not straight. Linear means it's a line, Ethan. So if I look at this, right? This is not a line. So it's not linear.
it is a line. What are you talking about? What?
Well, the data doesn't follow a line.
Shit.
Alright.
You see how like it's pretty bad at following a line, right? It's kind of like
Alright.
above and below. Yeah. So it's not linear. Sorry, let me put the screen here. So it's not linear.
I'm saying linearly related. I'm saying
It's not linearly related. It is exponentially related. You see how exponential fits it a lot better?
Alright. Exponentially related.
You can also look at the r squared value. R squared, the closer r squared is to 1, the better your fit is. This is 0.9999, basically 1. Linear, it's 0.95. That's not as good as 0.999.
Alright.
Cool. I guess it could be logistic too. All right, good. Swaz, what's up? You got some quick questions, or you got a
Yeah,
couple
dude. I was finishing up 41, but
more?
43 is it's getting me, man. It's getting me.
Did you send me a screenshot?
I did. Oh wait, did I?
Oh, wait, did you? I don't see it.
Nah, I didn't. Good
I
call
even
there,
found
man.
I'll
One sec. Foxy Forky
yeah.
Washier says, any tips for studying? Ooh, practice and doing things. I think too often students want to study by just reading, like going over their notes and stuff, and that's probably somewhat helpful. But the most helpful thing to do is to do things, as in do homework questions, do practice tests, do I don't know, quizzes, whatever. As long as you're doing problems, you're going to retain the knowledge a lot better versus just reading about it or I don't know, watching lectures. Some students just want to, keep watching the lecture and over again. I say that, the problem is that when you get to the test, you're not watching a lecture. They're asking you to do something. So the best way to do well on that is to practice doing that.
about that go?
Yeah, Shantrix, I like the 30-minute blocks. That's called Pomodoro timers, I think. Yeah, what's up, Ethan?
I heard about another math joke, but this one involves a song.
All right. Say the math joke. I'm getting Swaz's question up. All right, what's the math joke?
It's related to Old MacDonald how to farm.
Okay, Old MacDonald had a farm.
E-I-E-I-O. You remember that?
Yes.
Imagine having 2.7 blah 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 and a square root of -1 2 times. On
Oh,
different lines.
E-I-E. Oh, okay.
Yep. Square root of -1 is I, and the 2 point blah 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 is E. You see that?
Yes, I do see that. That's pretty funny. That's good. I like that. That's a funny one.
That can be for jokes.
That's a good joke. I like that joke, dude. Okay, anyways. All right, here, let me help Swaz because I want to go to the gym. Swaz, which one do you need help with? Swazi. Where's Swaz?
Hello?
Yeah, what's up? Which one?
43.
Suppose 70% of college women have been on a diet within the last 12 months. Sample survey interviews a simple random sample of 267 college women. What is the probability that 75% or more of the women have been on a diet? Oh, interesting. So, these are proportions, right? How does this work? I think standard deviation. Okay, so first of all, these are proportions. Because see how it says like percentage of students have been on a diet, right?
Yeah.
Percentage. Okay, so we got to go for one sample proportion tests, which are here. This is it. Love it. What's the equation? Or here, this kind of works. There's just a bunch of tests, and you use different ones for different situations. Okay. But, yeah, we're going to hide your email. Okay. So here, right, P bar is the sample proportion. So in this case, you're seeing 75%. So you're going to say, okay, 0.75 minus the population proportion. So all college women is the population.
What
So
are we
that's
testing them on?
What do you mean we're testing them on?
What are we testing them on?
We're just testing to see if 75% is like crazy different. Okay, you want to know why we're doing this? This is actually very interesting.
Yeah.
The reason they're doing this is to see whether the women at this college are different than the women at all the colleges. That's why this is happening. So let me just give you like the big picture of what this is. So here we have all women in college. Okay.
Okay.
And we say that the proportion of all women in college that go on a diet is 70%. That's pretty fucking high, honestly. Okay. And so that means that all of these other little colleges right here are going to have their proportion of women on a diet around 70%. So maybe like 0.72. Maybe this one has like 0.68. Maybe this one has like 0.71. Okay. Bless you. But then let's say that like some college has only 0.5. Right? Let's say some college has only 50% of the women go on a diet. What we want to know is this college different than all these colleges? Or is this 50% like within the margin of error that like it's just, you see how these like kind of randomly vary
Like an
from each
outlier?
other? Exactly. Like, is it an outlier? Like, is this not a college like any other? Like, is it significantly different? That's what we're doing. Okay. So in this question, they're saying, what's the probability that I find a college where its sample is 75% or higher? Okay. So what I'm doing is I'm finding a z value, because z values, let's remember, right, from this stuff. Let's say this is like z is equal to, what is this, like 1, I think, right?
Sure.
That means, and right, this is z is equal to -1. That means this is, I don't know, this is like 33%, right? Almost. Well, I guess it's 32.5. Whatever. I'm just going to call it 33. Okay.
I'm sure it's like 65.
It's 65 for the whole thing. So I'm just going to call it 66. Whatever, just to make math easy. So, depending on the z value you get, that tells you how likely it is to get a college that has that percentage of diet people or higher. If I get a z value from 75% being way up here at like, I don't know, like z equals 3, okay? That means that is very unlikely to find a college that has that z value because it's way off in the tails, okay? The z-score for a sample tells you how weird that sample is compared to the population. If the z value is close to 0, it means that sample is pretty much the same as all the other samples. If that z value is big, either in the positive or negative direction, that means that sample is very different from all the other samples. Yeah? Kinda?
Like skewed?
Skewed. Sure, it's an outlier, is what we say, right?
Okay.
Stuff out here is an outlier, right?
Yeah.
Yeah, okay. So that's what we say when they say test statistic. This is putting a number on, you know, how different this sample would be. So if I had a sample where 75% of the women were on a diet compared to the population where only 70% are, this gives me a z-value of, and then this is 1 minus 0.7, and then how many did they say were in the sample? 267, right? Okay. So n is your sample size, p is the population proportion. That's the regular percentage of students on a diet, which is 70%. Okay, and then you can get a z-value from this. So that gets you 0.75 minus 0.7 over the square root of 0.7 times 1 minus 0.7 all over 267. Okay? That's 1.78. That's pretty big. Okay? So, if you were to go to like a z table or something, I'm just going to use this. I can just give the z value, 1.78. Okay. This tells me right away that the probability of it being 75% or higher is 3.8%. See, that's 0.03?
Yeah. So
3.8% of colleges have more than 75% of the women on a diet. I know it gets confusing because you're hearing the percentage thing twice. You're hearing like, oh, percentage of this have a diet percent. Like, you're like, what? Like, you know. That just has to go with the thing that you're measuring is a proportion. You're measuring the percentage of people in the group that go on diets and stuff.
Yeah.
If this was instead percentage of women that have been on a diet, let's just say like the average number of drinks that they drink in a week or something. I don't know. Now this is no longer a proportion test. This would just become a straight up Z test, which would just be number of drinks minus the mean number of drinks over the standard deviation of the population over the square root of n. But because it's a proportion, because we're saying the percentage of people that are on a diet, we have to use this formula instead.
Okay.
Yeah?
You're
okay. So you can say the probability here is 3.8%. Cool?
Yeah.
Okay, what's up? I probably got time for like one more. What's up? Which one you want help with?
Me?
Yeah. Shit. He's like, you want to do all of them?
Yeah, man. I mean, I got two really easy ones. They're multiple choice. You want me to take a quick screenshot of them?
Okay. Raven says, how do you calculate probability? Probability is usually the number of outcomes that are a success divided by the total possible number of outcomes. So, if for instance, you know, I was in Vegas actually 2 days ago, and we were playing the video poker thing or whatnot, and I was like trying to calculate, oh, what's the probability that another ace comes out or something. So let's say for instance that you already drew one ace, and you're like, okay, what's the probability that if I draw a card, I get another ace? That's equal to the number of successes over the total number of outcomes. So in this case, if I've already pulled an ace in a standard deck of cards, the only way I can have a success to get another ace is to pull one of the three other aces. So there are only three ways I can be successful. The total number of things that can happen is 51. Because there were 52 cards in the deck. I pulled out an ace, so there's only 51 left. So there are 51 total cards left. So, good to see you, Shantrix. Yeah, thanks for being here. Yeah, we're this has been a 3-hour stream. We've been pretty long. Yeah, good night, dude. Yeah. What's up, dude?
I apologize for interrupting this, but I'm gonna go now. I got a lot of homework to catch up
No, I
on.
appreciate you being here.
Thanks
Yeah.
so much.
What were you gonna say?
Let me finish here. Thanks so much for helping with the 2 graphs to confirm it. I might be able to get hundreds on both of these.
Fuck yeah, dude.
And ever
Love
since
that.
I took a quiz about the periodic table and about like their atomic structure, only the first
Uh-huh.
20 elements, and I should get 100.
Well,
I
let us know how
checked
you do on it.
everything.
Yeah, let us know how you do on it.
So yeah. Can that picture work as for the 2 bond points thing?
Yes, it can work for good grades for sure.
And one last question. Remember your New Year resolution thing
Yes.
that you uploaded?
Yes.
Am I still able to do that? I
Yeah.
just didn't see it at the time.
You can do it. You can do it. It's okay.
Alright then. Later.
Later,
Good
dude. Okay, which one? Which one you need help with?
I get help with 48 and 50.
You're good to see your record. Yeah, you're good. 48 and 50. All right, let's see.
They're quick. They're multiple choice. You know.
Decreasing the sample size from 750 to 375 would multiply the standard deviation by. Good. So this is cutting the sample size in half. Okay. Standard deviation is proportional to 1 over the square root of n. Okay.
Oh, it should be D.
Mm-hmm. Yeah.
Uh,
Yeah, because if you're cutting it by a half, you're like multiplying it by 2, but it's the square root of that, so it's by the square root of 2. Yeah.
Yep.
Okay.
All right. Then 50 in a congressional district, 55% of the
Oh.
registered voters are Democrats, which the following is equivalent to the probability of getting less than 50% Democrats
okay.
in a random sample size of 100.
Oh, bro, this goes right down to it's this formula, right?
What, the one we just did?
It's this one, yeah. So it's p minus p hat. So yeah, p minus p hat.
So it would be 0.55 minus 0.5,
0.5,
right?
good, yes. And then it's this.
So it's
this.
just E or C.
It's C.
It's C.
Yeah. Right, because this is the equation for the
Oh
standard
yeah, no,
deviation.
because E is just that's not E is not.
Do you remember it was this, right? P1 minus P
Yeah,
over
yeah.
N.
All right.
Wait.
What?
Oh?
Wait.
What? Yeah, no.
Tony.
It's 0.5 minus 0.55. It's this one.
It's 0.5 minus 0.55.
Yeah.
Wait, so
this is-
0.55 is P hat?
No, 0.55 is equal to P. 0.5 is equal to P hat, I
But I
think.
thought it was P
Yes.
hat.
P hat minus P.
Oh, okay, yeah. Okay.
0.5
okay.
minus 0.5. Because then, yeah, and then this is all the P's. This is P, 1 minus P, and this is N. Cool? Okay.
Should be
Nice.
B.
It would be B.
Right?
Yeah.
Okay.
Nice. Good job. Okay, cool. Let's end out the stream. All right.
That's dope.
You're welcome, dude. Thank you for coming out to office hours. Had a really good time working with all you guys. Yeah. Provided the winds don't kick up tonight, which I don't think they're going to in my area, we should still be streaming tomorrow. That's going to be at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. Come on by. We'll help you out with some homework. I know the school year just started. Some of you guys have finals this week because you didn't have them over the winter break. I don't know. That's
Oh no.
kind of mean. Yeah, good night, Raven. Yeah. But yeah. I know, yeah, dealing with the wildfires, I haven't been able to really update the Discord in the last week. I will get through that this week. And there's a lot of really cool announcements because a lot of our friends, our Canadian friends, Penn Center and whatnot, are doing some really cool math courses that are free for you guys to do. Yeah. So again, yeah, go follow our awesome math streamers. If you want to figure out when they're streaming, there is the calendar. Let's go raid someone. Cool stream? Yeah, I appreciate it. You guys make it cool. Yeah, otherwise I'm just like streaming to the unknown. Right? Let's see. Who do we got? We are following Microscope Monday. Oh, that sounds fun. Fire Ants. Or we can watch Tinker just sleep. Okay. Let's go say hi to Science. They're cool. Oh, it looks like they're looking at a cookie? Is that a cookie? Wow, this looks like really cool. What the hell? This is a cookie that they're doing? Okay. Anyways, all right. Have a wonderful rest of your Monday. Wonderful start of the week. We will see you guys tomorrow. Peace out.
I promise.
We will not be dissecting actual education. Welcome on in, Raiders!
Science stream, but we ain't bugging. We over here about to leave. You be chugging what we got. Now the tribes arrive. I promise that I have prescribed you vibes. The vibes we got are giant. Shout out to the stream for the raid. That's science.
Raiders, welcome the heck on in. Actual Education, how was your stream? What were you up to today? Guys, check out our friend Actual Education, who does actually education. A lot of SAT prep, mathematicallys, and more. Y'all, how was the stream? Tell me all the things. E-Raven Violet, thank you for the follow. For the Raiders coming in, my name is Balint. 1/3 of Science streams. The other 2/3 are my wife, Lita, and our daughter, baby, Alona, a.k.a. the Munchkin. Lita and I are research scientists with our PhDs in molecular biology. And we do live science content here on Twitch every day of the week. We got microscopy, which is today. We got art, sci-fi science, science news of the week, deep dives into scientific topics. We got games, we got 3D printing, we got IRL streams, and more. Raiders, welcome on in. Today, Actual Education, fire ants are going under the microscope. In fact, we are popping open some fire ants. We're talking a little bit about the science behind them. Oh, the cookie.
Nice.
The cookie was actually their home. I may have popped off their home from Georgia and brought them back here so that we can look at it under the microscope. I may have been a little bit, how to say, charging into some science. Possibly, potentially. So that's what we're going to be looking at in just a few moments. We